be like this, but then the coefficient of the x squared is 0. Making this whole term 0. That was why in the question it did not come. Like I explained, this here has x equals x exponent 0. Just that we don't write it. We don't write it because that will always give us a constant. Any number raised to the power 0 is 1. Multiplying whatever is still that number. So we don't usually write it. It's just like here. You know that this 5x, x is raised to the power 1, isn't it? Is that not so?
Yes, madam, that's so.
Hello. Yeah, so that is how it is. So if it is saying arranging in descending order, you arrange in that order, and you say that include any missing terms with a 0 coefficient. Normally, when we are writing it and it has a 0 coefficient, we leave it out. Not that it is not there, but it's the coefficient of it is 0, and wouldn't change anything there. Just like when it comes to the 5x, we don't usually write 5x exponent 1 or 6x exponent 0. We don't usually write it, but that is it. So the first is to arrange it in descending order of powers. Then step 2, divide the leading terms by the first term in the divisor. So divide the leading term of the dividend. The leading term is this. When you say the leading term, after doing the proper arrangement, this becomes the leading term. Divide it by the leading term of the divisor, which is x. So you end up getting 2x cubed over x is equal to 2x squared. Now this will give us the first term of the quotient. If you remember what the quotient is, you are dividing something. So if I'm dividing 16 by 4, 16 divided by 4 is 4 remainder 0. So that 4 is my quotient. We just saw it somewhere. So it is talking about the first term of the quotient. So after me dividing, I'm not done. We are doing a long division process. But whatever we are doing as that kind of dividing is building this quotient. So whatever we just got is the first term of this quotient. By the time we finish, we'll get the remainder. Okay. So you take the first term and divide by the first term of the divisor. So doing that, we get a first term of the quotient, 2x squared. Now the rest is repeat, repeat, repeat. Okay, there's a third step before the repeat. It says, whatever you have gotten, multiply the entire divisor by the term found in step 2. So what did we get in step 2? We got 2x squared. We take this and we multiply it by the entire divisor, which is our x minus 2. And then we subtract the result from the dividend. So what did we get in step 2? We got 2x squared, and that is it here. And we multiplied it by the divisor. The divisor was x minus 2. We multiply it by the divisor. Now this whole thing is saying that subtract it from the dividend. So we subtract it. So this part is a subtraction from the dividend, which was the main thing that we started dividing from. So whatever you got, multiply it by the whole divisor. Then subtract whatever you get after the multiplication from the dividend. So when we do that, multiply this, we get 2x cubed minus 4x squared. And then we open the bracket, minus 2x squared. This becomes a positive 4x squared. Now we subtract the same thing. We are subtracting from here, or even from here, we are subtracting from the dividend. Now, at this point, all that we did was simplify. So we have this 2x squared. We have this 2x cubed. We'll cancel out this minus 2x cubed. And then we have 3x squared, 4x squared. When you put them together, we have 7x squared. Then minus 5x plus 6k. So that point is just simplify whatever you have, and then you get to this. Then the process will continue again. The process is, now this is our leading term. 7x squared is now our leading term. So we take this and then we divide by the leading term of the divisor, which still is our x, because our divisor is still x minus 2, so it is still x. We divide it by that, so 7x squared minus x, and it gives us 7x. Then do the same process again. Now this is what we have now. Multiply this by the entire divisor given, which was x minus 2. So that was what we did here. And this gives us 7x squared minus 14x. Subtract this from the dividend you are coming from. So now this is our dividend. And from here is where we picked the first term. Don't go back to the original question dividend, please. This is our new dividend. And we took the first term and we divided by the leading term of the divisor, giving us 7x. Doing the multiplication with the divisor, we have 7x squared minus 14x. Then subtract from the new dividend from there, what you got. So we subtract this from the dividend and we end up getting 9x plus 6. So now this is a new dividend to move on. So what's the leading term? The leading term is now 9x. It's now 9x. We divide by the leading term of the divisor, which is x, and we get 9. And then we get 9. Now multiply and subtract. 9 plus x is the new, where we are coming from. Then we multiply by the whatever we got by the entire divisor. So we have 9 multiplying x minus 2. And this will give us 9x minus 18. That's what we have here. And we subtract it from where we are coming from. And this, I'm sure, gave us, okay, so this gives us minus 9x plus 18. So it becomes, this cancels out 9x. Then 6 plus 18, it gives us 24. Now, it says at this point, the degree of the remainder, there's no x there. The degree, so when it's talking about the degree, it's talking about the power of the x. Or even, yeah, so this one doesn't even have. So the remainder, 24, is less than the degree of the divisor, x minus 2. So the process will stop. So if there's no x there again, you can't even further do a division. So the process stop. So the quotient of whatever we have done is, if you remember, the first one that we got 2x, then we came to 7x, and then we came to 9. And then we came to 9. So after the 9, then we have this 24. So the 24 here becomes it's not the 24 is the remainder. Okay, so the first one we had after the division, we have the 2x squared. We moved on, and then the second one we had 7x. This one, so 2x squared minus 7x, and then we came down here, and then we had 9. And then we have 24. So this 24 became our remainder, and this is our quotient. And this is our quotient. So before we move on, there's an exercise here for us to do. But then I want us to do the same thing using the long division for the question 2 of this. And we use the long division. So one of the factors was, I think, x minus 2. x minus 2 should be one of the factors. Yeah. So can we do it together? Or no, we'll do one together, but do this one. This was an assignment to do this one and see if you would get if you are sure to get this x minus 2 all squared, then x plus 2. Please, do you understand? Oh, no, before that. Maybe we just did one step. Let's do this one together, and then let's see. Let's do this one together, and then okay. So what should we do first? This an exercise. We are all doing it together before we go back to the question.
I think we should minus 4 equal to 0.
I can't. Pardon?
Are we going to equate x minus 4 equal to 0?
No, we're doing a division. We are doing a division.
So we rearrange in ascending order.
Okay, so that's the first step. Equating it to 0 is like last week when we were trying to find the zeros. That will help us to sketch the graph. So the second question, you needed to do a division to get all the factors. So what we are doing today is to help you to, if it's the polynomial is not that straightforward, it's just to help you also get the factors of the polynomial given. Then you can get to your zeros where you can get x is equal to. So here one of them is x is equal to 4. And if I should put 4 in here, let's try and see. So we can get what? 6 into 4 squared minus 26 multiplying by 4 plus 12. So 4 squared is what? 16. 16. Let me look for my calculator. So we
Madam,
have.
please.
Hello.
Where did you get the 4 from? Is it the 4
From here? Yeah. From the
me?
divisor.
I thought that was negative 4.
Yes, that is negative. Hold on, that is negative 4. So that is a factor.
Madam, this was what I was talking about. That we find the zeros for the x minus 4, so that you get 4 and use it.
Hold on. Let me answer the guy, then I'll come back to the lady. So this was what you're talking about, but then it has already been given. It says divide this by that. So definitely this one of them, if you should, that's why I want us to test whether 4 will equate this whole thing to 0.
Okay.
You understand? The question has been given that divide this by that. Whether that is a factor or not, that is the test that we will do. So that is just what I am doing.
Okay, madam.
I hope you get it.
Yes,
now
please.
to the ladies question. Yes, x minus, it is minus 4. You can see it as minus 4. But then when you pick the whole of x minus 4, it is different from x is equal to. So remember in one of the talks in this particular lecture, I was like, when you get the factor, you don't use it like that. You make x the subject. So it's like you equate the whole thing to 0, and now making x the subject, x becomes 4.
Okay.
But then this, as it stands now, is like a factor. So should I go back to any of whatever we were doing? You will get it in this form. So the x minus 4 you are seeing is a factor in this form. But the real zeros is when x is equal to 2 for this one and x is equal to minus 2 for this one. What did we do? We just made x the subject by taking each one of them, equating it to 0. So this is it. So it was like we should, the whole polynomial, we should divide it by this one. And that's just an example we are doing.
Hello, madam.
Hello. Hello. Hello.
Hello, madam.
Hello. Please, I'm here. Oh,
Madam,
you
please,
can't
we
hear
can
me.
hear you.
Somebody was asking a question.
We can hear you.
Okay, so this, you take one of the factors, you equate it to 0, and that number that you get is what actually helps you. So you see here, the zeros are actually minus 2 and 2. Now these numbers themselves, when you put them in the polynomial, it is, you get the polynomial going to 0. So initially, the first person who said, also attempted the question, said he did the guesswork and he got 2 and minus 2, and that is correct. But I was like, you may miss something. What is it? You realize that one of them has a multiplicity which is not odd, which is 2. Now when you do the guesswork, you can miss that, and then your graph will be different. So if you just use the 2 minus 2, his graph would have gone cross and then come down again instead of just bouncing off, because it was all purely guesswork. So when you get a guesswork and you get one of them to be 0, use the division to get the, if there are other factors, use it. Use it to get the other factors. So here, the x minus 2 was one of them. Like here, it looks like a guesswork, and we got 0. Then we use this using a synthetic division, not the long division we just did. I'll show you the synthetic one too. You use that factor that he got through the guesswork to find out if there are other factors. Then through that, he got another x minus 2, x plus 2, and ultimately this. So back to the lady's question, the minus 4 you are seeing there is a factor. That is just a factor we are yet to use. So at the end of it all, if you have this and you want to test if this is actually a factor there, then make x the subject here. How do you do it? Equate this whole thing to 0. Now x is equal to 4. That's why I'm putting 4 inside to see if this whole thing will run to 0. If it gets to 0, then I know this is a factor of that.
No, madam.
Hello.
Okay, madam. So, what you are doing is a guesswork. Why don't we go with the normal, step that you gave us?
And we no, hold on. I'm just trying. We'll go through that.
Because
That one,
what you just said was that the guessing work sometimes you might mistaken, and then the
exactly.
graph, instead of the graph
No,
bouncing.
we will go through that. All
Okay.
I'm trying to say, I just want to see if the this one, what you were given in your the assignment given, you realize that nothing of that sort was divided by that. Let me see if I'll get to the question. It was just this. This was just what was given. This was just it. And you had to find the zeros and sketch the graph. So the first guesswork was put something in and see if this will get to 0. But what we are solving now is you have been given divide this by this. So I am just trying to see if 4 is actually a factor of this. The two are different, but one of them you have to go through what we are now going to go through. So I am just, before we start the long division process, I just want to check if 4 will make this whole thing 0, because I've been given, they said I should divide this by that. So I am just checking. But if this was just given and you were to find the zeros and sketch the graph, you would have to start with your guesswork, because this wasn't given. This will not be given. You'll just be given the polynomial to sketch the graph. And it's your duty to find the factors. But this method, you can use it to find the zeros. Because that question in particular that we'll go back and answer, you were supposed to divide. So at this point, I've not started the long division process. I just want to find out if 4 will make this whole thing 0. That is just what I'm doing before we come to the long division process. So 16 multiplied by 6 will give me 96. 96 minus 26 multiplied by 4 gives me 104 plus 12. So let me see, 96 plus 12 is 108.
Madam, you're having the final answer to be 4.
Yeah, the final answer is 4. Yeah. The final answer is 4. So you see, this means that then x minus 4 is actually not a factor. You can use 4 to find the zeros of it, because we didn't get 0 here. This is just what I was testing. I was just testing. But then what we are actually supposed to do, we didn't tell us to find the zero, so it just told us to divide this by that. Divide this by that.
Madam, is the
Hello.
after dividing, you will not get a remainder of it.
We are likely to. We are likely to get. But let's see. All that we are doing is guesswork. I just wanted to know if I put 4 in there, this whole thing will be 0. It wasn't 0, it was 4. So let's go through the long division process and see. What is it saying? It's saying that we should arrange everything, all the powers of x in descending order. Now, I'm sure this is already in its form, isn't it? X2, X1, X0. So it's still the same. Or something is missing. So the first step, this is what we get, isn't it?
Sure.
Okay. Now the second step, step 2, is saying that what? We should pick the first term which is which is 6x. Let me see this one. Okay, so 6x squared. We should divide by the leading term of the divisor, which is x. And what do we get?
You get 6x.
Sorry, 6x. Now what do we do? Move on to step 3. And then it says that whatever we got here, multiply it by the entire divisor and subtract from the dividend. So we can have, let me copy this whole thing, minus into bracket 6x multiplying x minus 4. Or please, is that correct?
Yes,
Yes,
madam.
madam.
Yes, madam.
Okay, so what we did here was this, the 6x multiplying the x minus 4. The x minus 4 is a divisor. And this is the term that we just got from this step. So 6x squared minus 6 times 4, 24x. So this is what we get. Then we just simplify. So you know this will cancel that. And this 2 is sure to give us what?
Sir Jackson, can you kindly mute your mic?
Is that it?
Madam,
Hello. So this one
please,
will go away. We'll cancel this.
madam, please, I want to ask a question.
Please go ahead.
Please, the 24, must it be positive or negative?
Yes, it should
Hold
be
on a minute.
positive.
It should be positive. So this
Yes,
multiplying this is minus 24. Then
Thank
this will affect it. This will affect it. Yes,
yes.
yes, yes, yes. So
So it should be -2.
okay, okay,
Negative
all right,
2x. Yes.
okay. So this x multiplying that is the one giving us the minus 24. This is giving us the minus 24. Minus 24 affecting this bracket gets the positive 24. All right, so doing simplifying the whole of this, we get minus 2x plus 12. And then the next step, step 4, which is a repeat. What do we do? What we do is now, this is our term. This is what we got. So we'll pick the first term of it. Let me copy this. We pick the first term of it. And that will give us minus 2x divided by x. So we pick the first term of this, and then we divide by the leading term of the divisor. And that gives us what? A minus 2. That gives us a minus 2. Now, what do we do with the minus 2? The minus 2 multiply by the divisor, subtract from the dividend. Step 5, which is also a repeat. Or do you think there's something I should add? Okay, just for your learning sake, arrange. 2 is divide leading terms. And then step 3, I will push it like, we do like that. Multiply, subtract, multiply, subtract. Okay, so step 4, repeat. And get this. Then step 5, what we do is we have what? The minus 2 multiplying x minus 4. Now this whole thing, we are supposed to subtract it from the dividends, the new dividends that we have. So subtract it. And what's the new dividend that we have? It is minus 2x. Like that. So we have this minus, in the bracket there we have what? Minus 2x plus 8.
8, yes.
Okay. And eventually this gives us what? Then we have what? Positive 2x up.
Yes, please. And minus, yes.
Hey, no, wait.
It's minus
Positive
8.
2 minus 8. Minus
Yes,
8. Yes, minus 8. So then what we have is what? 4.
4.
I hope you get it. We have 4. Now 4, can we go on or we have to stop?
Madam, you stop.
We have to stop because, yes, because it is saying that English there was like the power of this is less than the degree of the x, the leading term of the divisor. So for a layman, what I'll say is if you are dividing by the leading term of that and there's no x in it, please don't do it. To the layman, for those who are struggling. If you are dividing, so the repeat, you can go on and do it. When do you stop? When you know that now this is our term. This is what we have. If you are to go on, you get 4 over x. This 4 even doesn't have an x to divide by. So just stop there. When we were coming, we had 6x squared. We did the division. Whatever we got, we had minus 2x. There was still an x. We did the division. Now here, we don't even have x. So we stop. So for those who don't understand, because the degree of whatever we have is less than the degree of the division, please, if you don't understand that one, all I'm saying is when you're dividing and there's no x, don't divide. Stop there. Stop there. Okay. So now what will be so we are done. The long division process is done. So what is our quotient?
Madam, please let me try 6x minus 2 plus 8 over x minus 4.
Minus 2 plus what?
8, 4.
Plus 4 divided by
x minus 4.
X minus, oh yeah. Sorry. So let me do it well so that somebody doesn't.
Madam, I think the quotient should be 6x minus 2 or
please let me use a proper equation so that it is 6. Oh no. So I have 6. What am I doing? 6x. So I have 6x minus 2 plus 4
Divided.
So this is answer. Yeah. Please, somebody was asking. I heard you say the answer should be 6x minus 2.
yes, please.
That's minus 2
But
plus.
you don't forget the remainder.
Yes, the remainder is 4.
So that part is also important.
But okay,
I
yeah,
think
yeah.
you said that because you asked of quotient. That is why.
Okay. Yes, the quotient is just this. This x minus 2, that's the quotient. Then that is the remainder. That is the remainder. So all in all, dividing this by that, that is the answer. The quotient is the terms that you got before the last one where you stopped becomes your remainder.
Hello, madam.
Hello.
I used a different approach. I don't know if it is acceptable.
A different approach.
We are even confused here. You are bringing another approach.
There's another one they call the synthetic. We'll do that. I don't know if that is what you used, but whether you use the synthetic or this, you should get the same answer. And I'm sure this is correct. So if you're not getting what we are getting, then yours is wrong.
Hello, madam.
If you can,
Madam.
Yes. Hello.
Please, some of us, our network is not stable, so we lost off and on, off and on, off and on. So if you
Please,
take your
is
task
nobody
for
recording for me?
Sure. Please, yeah, they are recording it, but madam, please, I beg you, there's step 3. Kindly go by again for me from the step 3.
I'll start from step 1.
You lost on the way, and the network problem.
I hear. Let me start from step 1. Step
Yes,
1
please.
is saying that arrange the dividend given. Arrange it in descending order of the x powers, the powers of the x. So meaning you see this x. If it was starting from x raised to the power 5, that means there should be x raised to the power 4, x raised to the power 3 in that order. So arrange them in descending order. That is all that it is saying. Now for this question given, we are starting from x squared. So it's x squared, x is here, and then x raised to the power 0. So it's already arranged nicely, and none of them was missing. If some of them was missing, we will bring it, and the coefficient will be 0. Coefficient means whatever number is before the x, we will say 0. So for this, we were lucky, none was missing, everything is just smooth. So that is our dividend. Step 2 is saying that take the leading term of whatever you have arranged and divide by the leading term of the divisor. This is our dividend, this is our divisor. Divide it by it. So the leading term is 6x squared, and the leading term of the divisor is x. So we did the division, and we ended up with 6x. Now this 6x, the next step is that the whatever you have gotten out of the division, multiply it by the entire divisor given, and whatever you get, subtract it from the dividend. So that is what we did. This 6x, we multiplied it by x minus 4. That is what we did here. So whatever we get here, we subtract it from the dividend. And this is our dividend at this step. So we go to the rest as simplification, and then we end up getting minus 2x plus 12. Minus 2x plus 12. Then we are not done yet. The algorithm says that we should repeat until a certain condition. The condition is not here, so we do a repeat. We take the first term again, just what we did from step 1 to step 3. That's why I'm saying repeat. So we take the first term of the new equation that we have, and then divide it by the leading term of the divisor. So we have minus 2x divided by x, and we got minus 2. This minus 2 that we have, we multiply it by the entire divisor. That's the step 3. We multiply and then subtract from the dividend. But the dividend, don't go back to the original question. The dividend of where you are now. So this is the new dividend that we have. And that is how come our leading term was minus 2x. So we pick that, we get minus 2. Minus 2 multiplying the divisor here. That is what we got here. And we subtract it from the new dividend that we have. So this whole process was just simplification, and we ended up with 4. Now with 4, I asked whether we can go on or not, and then he said we should stop. And yes, truly you will stop, because if you have to divide, there's no x to cancel anything. So I said, even if you don't understand the English that was said, when you are dividing and there's no x in the leading term, please stop. So we got 4 here, and then we didn't continue again. So this 4 becomes a remainder, the answer. So the quotients are what you got out of the divisions. You put them together, starting from the first. So we have the 6x, and then we have the minus 2, and then this 4. And since it's the remainder, it is 4 over the divisor. Just like when we're starting. If you divide 47 by 5, you get 9, which gives you 45. The remainder is 2 over 5. So that is just what we did.
Please, madam.
Yellow.
With the first step, the arrangement, in case there's something missing, assuming the S square is missing, and you need to arrange it and bring the coefficients of it to be 0. So I want to know, does it affect the final answer, or they just want you to, they just want to know if you understand the arrangement?
If the coefficient is 0, I'm not sure. Yes, it may affect the final answer, but then I'm kind of sure, assuming if it is starting, if the question started from minus 26x plus 12, please, you don't bring the square. That is where it is starting from. Did you see us bring x cubed here?
No, I understand that part. I'm just assuming if like we have
so
x
this
cube.
one was 0. Is 0.
Assuming we have x cube first, and there's no
and
x square.
So if it was x cubed, assuming this is x, let's say, let me change it back to x, and then this is cube.
Yes, please.
Okay. This is cube, and then so assuming this is the question. If that is the question, then I'm sure in your arrangement
you need to bring
the square.
The coefficient to be 0 and the x square.
Yes, 0x squared.
Exactly.
Yes.
So that's what I'm asking, if it's going to affect the final answer, or they just want to know if you understand the arrangement.
Oh, probably it will affect the maybe. So you can set a question like this and answer. I'm sure probably it may affect it, or it may not. But then once it is x cubed and this is 0, I'm not sure it should affect it too much. But then we can set a question like that and solve. You can set a question like that and solve, because this question here, you don't expect to solve this question here and get to this answer. I don't know if you are getting me.
So, madam, please, I have a question. If the answer is not the same, if you bring it and the answer is not the same, that means there's an error, right?
No, hold on. No, we are starting from somewhere. Are you expecting to get this answer for this question?
No, but there is a different question, madam.
Yes, this is a different question. Exactly. Because now the power of the whole thing, the leading degree of the leading one is now 3, and the x squared is nowhere to be found. So this question is entirely different from that. But then I would want to say that if you should go this way, and you should go the way I am coming to teach, the second one, and you don't get the same answer, then there's a problem somewhere. But then before, some that's why mathematics is interesting. You realize that when I was testing whether 4 was a factor, what did we end up with?
We had 4.
It wasn't 4. It wasn't 0. It wasn't 0. We had 4. So now this remainder here should give you a clue why those ones were giving us zeros, meaning that they can completely divide whatever was given. So if say something is a factor, that means when you divide that thing, you don't get any remainder. You don't get any remainder. So 2 is a factor of 4. 3 is a factor of 6. If you should divide them, you don't get any remainder. So what I started doing, it was because they have given me this, I just wanted to see if this is truly a factor. But then this is completely different. The objective here is different from find the zeros. So this is not a factor. If you are to find the zeros, x minus 4 is not a factor of this. Because if you put x equals 4 into this, you will not get 0.
Okay, madam. The place I'm a little bit confused is the last part when you were substituting the finances, the -2 and then 4. The latter part where we have 6x minus 2 plus 4. Yes. How did you do the substitution, please?
So the first one is coming from the first term after the division. Then this -2 is coming as a result of this one. Then see, we couldn't do any division again. So then we are done with the quotient. The rest is the remainder. 4 over that. That's why it's only 1 with the over x minus 4.
Okay, so the divisor was divided by 4.
No, this is a remainder, and this is how you write the remainder.
Okay, so you write it 4 over the divisor.
Yes. Whatever was left over the divisor, exactly. So I think it was even solved here. And it's the same answer we got. It's the same answer that we got. So there was a follow-up question. Oh.
Rabbi, it was the same question that I've just asked.
Oh, okay. All right. So, I would let me give you like 3 minutes. 3 minutes to use this long division to solve for the question 2. Yes, x cubed minus 2x squared minus 4x plus 8. Use the long division to solve it, and let me get your answers. Then possibly the the division that your friend did and put on the platform there, possibly you will understand what he was doing. So the first x cubed minus 2x squared minus 4x plus 8. Let's use x minus, let's divide it by x minus 2. X minus 2. Yeah, let's use x minus 2. I don't want to change it. The divisor should be x minus 2. Let's use this one. So 3 minutes. So I'm coming in. I'll come back to that, please. I just want to see. Are we on course?
Yes, madam.
Yes, madam.
All right.
Yes, madam.
Yes.
Madam,
Hello.
please, would we get x squared plus 4?
Yeah, I think I got the same thing.
As what? as a quotient.
X squared plus 4 because the remainder is 0, so you can't have 0 over.
I got x squared
It is
minus
x squared
4.
minus 4.
Yeah, I'm sure it should be a minus.
Yeah. X squared minus 4.
Yes.
That's what I got.
Okay. And that is
So,
correct.
madam, after getting the n squared minus 4, without the remainder, what happens to dividend?
Pardon?
After getting the n squared minus 4, now the remainder is 0. So
Zero.
if you, yeah, so it will be 0 over x minus 2, which will also be 0.
So it is
So
0. So that is why
we
they are
leave it
saying
like
x squared
that.
minus 4. Yeah, we leave it
Minus
like
4.
that.
Okay.
X squared
Thank you very
minus
much.
4. So you realize that if you do
Doc,
this,
Doc,
hello.
in fact, some of us, the answer we had, it is nothing to write home about. What I'm having right here is very odious. Please, if you could, kindly go, through for us. So, thank you very much.
And that one, I'll leave it to one of you. And I wish it would be a girl to explain to you. I'll leave it for a lady to explain to you.
Madam Mavis will do that.
I hope so. I hope so. Please, she will explain. Now I'll be listening. If there's any, and I know some of your friends too will know. Otherwise, possibly I'm doing that not because I don't want to answer. I'm doing that because I have said it. And what different am I going to say? Maybe when your friends say it, you understand it well. If they don't say it well, I'll step in.
Oh, Doc, we have understood it, but the problem right now is that somewhere in the middle, we have lost, together with my brother,
Yeah.
John Edet.
Yes. So I'll allow your friend to go over so that you
Madam
know.
Who told you I'm lost?
You
Who told you
know,
I'm lost?
you
Is
know,
also here.
he said I'm lost. So that you know where you went wrong.
Madam.
All right.
There's,
Yes, we'll go through again.
Sorry, there's this I just want to add.
Uh-huh.
In case where the problems comes, when you get the quotient, I think you should identify it. Wherever you get your maybe the new dividend, you should identify it because you need to come and be subtracting and be multiplying. So if you don't identify it, you are just going on and on. It gets confusing. I think that's where the problem lies.
Well said. What he's saying is, when you do the division, when I was explaining, I said it. Okay, let me go and come back. I said that when
please mute yourself.
So I said that you take the first term of the question after arrangement and you divide by the first term of the divisor. You will get something. Whatever you get, multiply it by the entire divisor. Take it out from the dividend at that particular level. Don't always go back to the question. So this one, the next step is to multiply by this, subtract from this, because this is where we are. And that was the step 3. So this was what we got. We multiplied it by the entire divisor and subtracted it from the dividend at that level. Simplification, we got this. So this is now what we are going to work with going forward. Don't go back to the 2x cube. So this that you get, the leading term is now 7x squared, and that's what we took and divided by the leading term of the divisor. We got 7x. Now this term multiplied by the x minus 4. Is it x minus 2? Yeah, x minus 2 for this. It's x minus 2. Okay. So multiplied by the entire divisor given and subtract it from the dividend of that level. And the dividend is this. Don't go back to 2x cubed. So when we multiply by the entire divisor, we ended up 7x squared minus 14x. Then we subtract from this. Which is this new term we got here. This new equation we got here. So at every step, your subtraction is different. Your subtraction is different, but whatever after the division, you multiply by the original divisor. If it's x minus 2, it's x minus 2 forever. And when you're subtracting, you subtract from the new equation you got out of the multiply and subtract step. If you keep going back to the original, you may not go anywhere, and your answer will be wrong.
Madam, please, I would like to talk about how I did mine, but I didn't get the answer. So that if I get it wrong along the line, you correct me.
Okay.
Yeah.
I hear. Please can I finish this one?
Okay.
And that's the final answer. You get x squared minus 4. The final answer is x squared minus 4.
Hey, madam, correct.
You are correct. Then please,
Wow, clap for yourself.
Please explain. It's x squared minus 4. You have done well. So I am writing it here because I want to explain how come in the notes there, the whole thing was x minus 2. X minus 4 will give you another x minus 2. Then you have your, I think, x plus 2. So the two of them, that is how come you got this. So from this x squared minus 4, that is what is giving us this 2. That's what is giving us this 2. Then we added the x plus, I think, no, the x squared minus 4 would give us, either one of them is x minus 2, x plus 2.
Yes, please. X minus 2 and x plus 2.
Yes, x minus 2, x plus 2. Then you add the one that you used in the division. The one that you used in the division. So from here, we get 2 of them. This is as a result of this one. Because when you put this one, x equals 2 into it, it will run down to 0. So that's the first guesswork that we did, x minus 2. Then we use that to do the division and got the x squared minus 4. Now this x squared minus 4, should you try and expand, or it's one of the rules, you get x minus 2, x plus 2. So the zeros of this equation, it is these 3. But I see 2 of them are the same. So that is how come one of them was squared and the multiplicity came for it to bounce off the curve, the line. But what I was trying to say is, if you do only the, please, I'll come to you. Yes.
I have a question. The previous slide.
This one.
No, the one you just. Yes, one. Yes, madam. This one.
Yeah.
Please. The final answer is x minus 2 squared, all squared plus times x plus 2. But x minus 2 all squared will give you x minus 2 times x plus 2. So it seems the plus, the second one is repeated. Oh, madam.
X squared minus 2.
X minus 2 all squared. Madam, if you expand it, you get x minus 2 times x plus 2.
Which
and the
one?
other one is the x minus 2 all squared. Yes, please.
All squared, yes. You get
Madam,
what?
X minus 2 and x plus 2.
No,
I mean
hold
the
on.
squared.
No. I'm not.
If you are expanding the squared, no, you will get x minus 2.
Which one are you expanding?
Madam, they're all squared.
The x minus 2 all squared.
All squared. Yes, please.
You want to expand?
Yes, please. You get x minus 2 and then x plus 2.
Oh, okay. Now I'm getting you.
And then the
So you are
is
saying that So that means this should have been minus. Sorry.
Yes, please. Yes, please.
Yeah. Okay, I get it. I picked it straight from your notes, so you have to be careful in your notes there. So
okay, thank you, madam.
Yeah, you have to be careful. I picked it straight from your notes over there. So I think in writing there are a lot of mistakes over there. So in there, meaning that roughly it's really supposed to be this. So this will give one of the plus, one of the minuses. One of the plus, one of the minuses. Now, if it happens, now when you get it like that, now x squared minus 4, do you agree that this should be something like x squared minus 0x plus 0x minus 4?
Come again, madam.
Please come again.
Agree that x squared minus 4, x squared minus 4. Do you agree it is the same as x squared plus 0x minus 4?
Doc, there's a problem.
Yes, please.
Yes, please, madam.
Doc, there's a problem.
What's the problem?
Doc, the problem right now is that together with John and then my wife, Mavis, we are even lost as to why you got the x square minus 4, and then it seems you are elaborating on it. So if you could kindly,
we'll come to that.
Madam, let's come to that because we are more confusing.
Okay.
Yes, please, we agree.
Where should I put this? So it was this
Jackson.
that we are trying to.
Jackson.
You know.
Yes, sir, David.
My brother.
You can go to you. Let's go
today. Solomon, John, and I, we are finding it very difficult. It's not easy at all.
Let's go for it. Let's go to. Want to divide this by that
now.
So what do? We have what? X cubed divided by, I have to use and then we have that. So step 1, the arrangement is okay, nothing is missing. Or cube
Yes,
2.
it's okay, nothing is missing.
Doc, this is not the question. The question was minus 2x raised to the power 4 minus. Madam, are we doing the first one, the minus 2x raised to the power 4, the x cube?
No, we are doing the s cube minus 2x.
Oh, it's rather unfortunate.
Me too. I'm now now I'm confused. I was doing this, you said no, we are lost here, and now we are all doing this so that we come here. So which one are we doing now?
Madam, proceed with the s cube minus 2x squared.
So we have the first term here, so the arrangement is okay, is the x cube all over the divisor is x, and this will give us what? X squared, and this will give us x squared. So now this that we have, we will multiply by the entire divisor and subtract it from this dividend. So we have what? X squared now we'll subtract this from its copy and paste this here. Okay, so now the whole of this
Plus 2x squared.
please, is that correct?
Yes, please.
Okay. So finally, what do we get?
You simplify and have, I had minus 4x plus 8.
Okay. So we are moving on. So we have this term. And the next one is to do what?
Divide 4x by x. The first element of the division.
So that's divide by x, isn't it?
And then we get what? Minus 4x.
Pardon?
Minus 4x. Minus 4x.
Oh, yeah,
Minus
okay.
4x.
So this is what we get.
No, please. The answer will be minus 3x.
Hold on. Now we
minus
get this term.
Divided by 3. Divided by x.
The answer, that's the answer, minus 4.
That's the answer, minus 4.
Hey, I'm confused. Sorry. That is why I got it wrong.
A very short answer. A very short answer. Please. there was this gentleman who said, me and my wife and Madam Mavis. I'm not sure if I got all the words, all the names correct. Please, are you okay?
Madam, please, I'm okay here. I had it wrong from this angle.
Madam. Okay.
Madam.
All right, good.
Instead of cancelling out the x, I rather subtracted 1x from the negative 4x. So I had negative 3x, so I was lost totally. But now, please, I've gotten that.
No, but when you look at this whole thing, gentlemen, please, I'll come to you. This one cancels out this one, and then this 2x squared will cancel out this one. So all that you are left. So if you happen to get this as your answer, and you have it here, where is the 3 coming from? Because all that you need is to take the leading term and divide by the divisor. So why are you subtracting again?
Madam, sorry, I have gotten that. In fact,
okay, I hear. I hear. Please, this is math, and it demands your full attention. It demands your full attention. Even if now, when you are asking me of the minus 3, now I was even getting confused myself. Sometimes when you even lift your head from the paper and talk to a friend, by the time you come back, you lose like 2 minutes because you have to understand where you are now. There was a gentleman trying to talk. Please go ahead.
Yes, please, madam.
Mm-hmm.
I've been really confused a lot that I can't even speak. But now I just got this part. I just got this part, and then I got the -4 plus 8. But with -4 x divided by x is equal to -4. That is why I'm confused.
Okay. This side.
Yes, please.
Yeah, so how did we get here? Now our new term is -4x plus 8. That is our new term from this step. If you do the simplification, you get -4x plus 8. Then you do the process again. You take the leading term. What is the leading term? -4x. Divide by the leading term of the divisor. That is what we are doing here. Whatever we did here to end up here, this is the same thing we are doing here. Take the leading term of the new equation that you have.
Okay.
And divide by the leading term of the divisor, and it gave us -4.
Okay.
-4. Now, if you proceed and you multiply and you subtract, you end up getting 0. That's why we didn't even do that one. You have -4 here. If you like, subtract it from this and multiply it by, let me go there and see. So what do we have?
When I did that, the whole thing has become 0.
Yes. That was why a friend of yours was saying that, so do we write 0 over the divisor? And I was like, if you write it 0. And no proper mathematician will write that part. It is 0. Unless maybe you are teaching. 0 over anything is 0. So it will not come. So that is why this person here is a true factor of this equation. Because when you put x equals 2 into this, it will be 0. So what I did from the beginning, trying to test whether the other one was 0, I just wanted to see if it was a proper factor, but it's not a proper factor. You get a remainder. So for yours, this part was not given. This divisor was not given. The question was, the polynomial was given, and you were asked to find the zeros and sketch the graph. So it was a guesswork to test what numbers will let this whole thing be 0. And one of them was x equals 2. X minus 2 also works. So you take it, and then I was like, don't do a full guesswork. After you have gotten just one, use the division rule to find the rest of the factors. And this is what we end up getting. So like I said, if you were to do the next steps, you were getting this minus into bracket -4 multiplying x minus 2 and so, and that is going to give us this is it plus 4x plus 4x and 4 is it, this will give us -8 this, and this gives us a +8, and this makes it a -8, and realize that this will cancel out that will cancel out that, and you end up getting 0. So this is the answer, and this is coming, this is the quotient, no remainder is 0. So we have this x squared coming from the first term here, and this -4 is the one here. So this is what we have. Now, if you should go back to one of this thing, I don't know, was there somewhere? I think it was from the very beginning of the. Okay, not entirely. Not entirely. And then from one of this, you should be able to do the 4x squared minus 4. And that is the one giving us. So I wanted to show you that I wanted to say that now that we understand the x squared minus 4, this was what I want to show you. That do you agree that this x squared minus 4, it is the same as this is the same as x squared minus 0x minus, no, it is plus rather. It's not minus. Do you agree it's the same thing as this?
Yes, madam.
Yes, please.
Now, when you have this, can you factorize? Can I have two numbers that when I multiply, I'll get minus 4? When I add, I'll get 0.
Yes. Yes, madam. That will be negative 2 and positive 2.
Exactly. So negative 2 and a positive 2, that is where from this one, we ended up getting x plus 2, x minus 2. Then I'll add the other x minus 2. When I say the other, this one.
Yes.
So this one gave us this other 2, and this one is from coming. So that's how come we have 2 of this and 1 of that. 2 of this minus 2 all squared, then x plus 2. So that's
very confusing.
Doesn't matter confused.
I'm confused.
Let's give which confused?
The latter part.
Which latter part? It is this one that we
where you are now. X
here.
Exponent 2 yes.
So this 2, it is minus 2 and positive 2. That will give us two numbers that when you multiply, I'll get minus 4. When you add them, I'll get 0. Minus 2 to give us 0. So the factors of this are x plus 2. One of them is plus, one of them is minus. Only this.
Okay.
Only this one. Then this red is as a result of that red. Okay, let me do it the other way around. So you get the one in black, and this red is as a result of this one that I just brought down, which is coming from the guesswork. That is all.
Thank you
it's
very
like
much.
you have 2 of them. Yes, you are welcome. 2 of them getting that. Please let me finish and then we'll go for the break, because we have one last lecture and I was thinking we will start that after the break. So the rest, this is the long division part. Now we have another one. So this is just it. We have another. Is it the same?
Please, madam.
Hello.
In fact, with all that you've done, my network, I couldn't hear anything. I couldn't get anything. So what are you going to do about that?
So there's a recording. There's a recording.
Okay.
I'm sure you go through that. Now that you have come, please follow. The synthetic. The synthetic one. Let's go through the synthetic one quickly, which is also quite very simple. There are even advantages. it is saying that it is faster and simple than the long division. It requires only basic arithmetic, works only when the divisor is of the form x minus. So if you don't have the divisor in this form, please don't use the synthetic. Now let's move on. So we have this, and we want to divide by that. You have this, you want to divide by that. You are not using the long division, you are using the synthetic one. Now, the first step is saying set up the synthetic table. How do we do that? All the coefficients in the dividend, write them down. So this 2 is as a result of this 2, minus 6 is here, plus 4 is here, minus 8 is here. This 2 is the, from the book, it is saying, write C equals to the root of, on the left. So maybe possibly that is the 2. That's 2 from the divisor coming, that is the 2 here. So you write all the coefficients of the equation, the polynomial, in here. The divisor C equals 2, so because it's of the form x minus t c, so it's like when you equate it to 0, x becomes 2. Then you write it there. Now, what you are going to do is the first 2 here, you bring it down. The first coefficient, which is 2, you bring it down. What you are going to do is multiply whatever you have here, the c that you brought here, the from the divisor, the c that you got, x equals c that you brought, whatever you have there, multiply by whatever is down here, and write it under the next. In your book, it wasn't like that, but then it was explaining, and I picked it from your book. So you take it, so 2 multiplying 2 is 4, we write it under the minus 6. And then from there, you just do addition or subtraction, whichever is there, just add them together. So 2 by 2 is 4, I put them here. Minus 6 plus 4 gives me minus 2, and that is what brings us here. That is what brings us here. So, and that's how you go on like that. So later on, you multiply these 2 again by the new one here, you get minus 4. You write it under the next one. 4 minus 4, you get 0. That's what brings us here. 4 minus 4, you get 0. You get 0. Then you continue. 2 multiplying 0 is 0. Minus 8 plus 0 is minus 8. Then you are done. I'm going over again. If you are setting up your synthetic division table, all the coefficients in the polynomial, you write them down. This is the 2. This is the minus 6. This is the positive 4. This is the minus 8. This 2 is as a result of x minus c, but then we make it x equals to c. So the 2, you bring it here. What you do is the first one, bring that one down just as it is, the first one. You bring it down as it is. Now you do multiply. You do multiply and add. Multiply and add. So 2 by 2, 4. I put it here. Minus 6 plus 4 is 2. You bring it down here. 2 multiply minus 2, minus 4. 4 minus 4, 0. 2 multiplying 0, put it here. Minus 8. Minus 8 plus 0. That is it. So you do that, and now how do we write our quotient and remainder? The last number is your remainder. The last number is your remainder. The other numbers preceding the last number are the coefficients of the quotient that you are coming to write. So what do we have? We have 2 minus 2 and 0. So this is it. The 0 will be the x exponent 0. The next one would have the power 1. The next one will have power 2. That is how you write it. So 2x squared minus 2x plus 0x exponent 0. It's still 0. So you can leave it like that. And the remainder is the minus 8. So then how do you write it? The quotient comes and the remainder comes. And don't forget the 0 was there, but because we don't write 0, we don't write 0. So this is how you write it. So then, in addition to this exercise, the first one, I'll go back so that you write it. The x cubed, it is x cubed minus 2x squared minus 4x plus 8. Let me see if I add it. Now do these two exercises. I'll come back and then we will continue. X cubed minus 2x squared minus 4x minus 8. This was the one that we just did for the long division. Now use the same thing. Use the synthetic method and do these two exercises. I will be right back.
Yeah, some more.
Why that?
But nothing there for human mind here.
Nice. Nothing there for your mind.
Five.
Zamavis. Zamavis.
Yes. Yes. Matthew.
The network.
Please, has anybody gotten an answer for the Please, has anybody gotten an answer
I'm
for
number
the
one.
first
My
one?
network.
Yeah, the first one you get x squared plus x minus 6.
Share your answer. Share.
Will be 1 minus 6. The remainder will be 0.
1 minus 6, right? And the remainder will be 0.
Yeah, the coefficient will be 1. The minus 6. The remainder 0.
Yes. And the remainder 0. Okay.
Festus.
Yes, I'm here.
Yeah, Charlie, you know, foresee me in chambers, so because they say me, my network they breaks, and I lost my wife. No be easy. Where's the message? Where I come tap upon you know, you go love. Still, the network breaks. I don't know.
We go fix up that law.
By a bit family slow.
Never found.
Ebe fa. Yeah, the AI be boy who near solve ebe fa.
But if you not make mistakes for not bring these questions, so these questions are we want.
Oh, my brother, share your screen and let's all dab.
Yeah, share your screen and let's see your approach.
The one
Some
who
of us
got
now that the network is stable small. First
my
off, share
brother,
your screen.
Michael, immediately madam left, so network is stable.
Let me see if I
No,
can.
it's not that stable. I was
This
working.
spiritual matter.
I was working. Hello, I was working, so I got to a place there at tap. I walked to a certain school, then to see I get there now we come. So
okay, and you got there and madam left too.
I got as I reached now, then she was explaining the synthetic one.
Oh, okay, so you got that one, eh?
I just go a slight bit of it.
Okay, my brother, Mr. Festus, please share your screen for us.
All right, in a few minutes.
Maybe after here, I'll see you in chambers for explanation.
I'm not talking.
You're not okay. Hey, I was thinking of falling on you for more explanation. Hey, then it means
You better rise. You better rise.
Is it Christy or Esther?
You said.
Christy, take us through the first one, okay?
Is it the division method?
Yes. So it means that the first one will be 1.
Oh. Yes, using the synthetic approach.
So then we have 1, 7, 6. Is that it?
You have to add the signs. So we have 1, -7, and 6.
Yes.
So you repeat the first coefficient, which is the 1, under the 1 again.
Madam, please let me chip in this and see. You see the first one is S cubed, right? So if you should arrange it, there should be S squared before the 7x. So I think some coefficients of 0 will be somewhere.
So it will be x cubed plus 0x squared minus 7x plus 6. We arrange the coefficients to have 1, 0, minus 7, and then 6.
Exactly. That's what I'm saying.
Then the C will come out. The C is 1. Please, am I right?
The C is 1.
Okay. It means that the first one, like the normal one, the coefficient of x cubed, that one will come down. So when it comes down, you multiply the C, which is 1, by that one. You will get 1. I will place it under the 0. And hey, that place, please do we add or subtract? Hello.
Hello, Christy.
It's Esther.
Hey, sorry. I didn't check that.
Hello, please can you see my screen or?
Yeah, we are seeing
You can see your screen.
Esther, initially you were explaining the synthetic
Yes.
Just increase the font size.
So we are going to write 1, -7, and 6, right?
You have 1, 0, -7, and 6.
Where from the 0?
You see, it is x squared minus 7x plus 6. When we
So
arrange,
we should get from
Arrange
descending
it.
order, we should get the powers of the square too, right?
yes, please.
So we have 1 0 negative 7 6. All right.
Yes, please.
Then we'll put the one below the 1.
Mm-hmm.
Then we have 1 outside already. So 1 times 1 give us 1.
Mm-hmm.
Yeah.
Mm-hmm.
So put that one under the 0.
Yeah. Then
So-
another 1 times 1 gives us 1. Then to the next go ahead, please.
So so under the 0 we have 1. So we add 1 to 0, it's 1. So put 1 there.
Yeah.
So we multiply the next one. 1 times 1 is 1. We put that 1 under the negative 7. Did you get it?
Yeah. Yes. Is it not going to? I thought initially before we
We
came
need to
this,
add something. No?
we add yes. It
Yeah,
was
so
2 times 2, 4. 4. Then we subtract. We added 4 to the negative 6, the initial one that we did.
Yes.
So 4 negative. So when we are getting 1, then that will be minus 6, I think.
yeah,
Yes.
they get minus
Yes.
6.
So
Yes.
minus 6 below the minus 7, right?
Yes, please.
Then minus 6 times 1 gives you minus 6.
Yes, please.
Then when we are adding it to the 6, we'll get 0.
Yes, please.
All right. So at this point, what do we do?
So unless I want to correct you, like I got.
Someone is presenting, so let us listen.
All
to
right.
him.
All right. Thank you.
Okay, so we have the 1. That is the divisor being x minus 1. So we write the 1 there. I have written the equation just as our lady was helping us, just as she said. So this one will be
Please, I want to find out, did Madam strictly told us, I mean, did Madam inform us to use the synthetic aspect to solve this one? I want to find out.
yeah, that is what she said.
That was the
Solving
instruction.
the first one, she said we should use that one to solve the 2 questions he gave us.
Please let's go on Festus.
So we will have we will write the coefficient of x. We will write the coefficient. So we have 1. Then the next one will be 0. So we bring the 0. Then the next one will be negative 7.
Negative 7.
Then the last one will be 6, which is another way positive 6. I prefer writing the okay, so I will leave 2 space. Then I will write, you will bring the 1 beneath. The reason why I have left 2 spaces is that I want to write when you multiply the 1, when you multiply this, then you subtract it from there. I want to write it here so that it will be easy for you to understand. So now we multiply this 1, we multiply this 1 by this, then we will write it beneath this 1. Then we write it under the 0. So we have 1. Do you get it?
Yes, please.
Hello. So when we have something like that, then we come again. Now you multiply the 1 over here, this 1 over here
by this one.
Hello, by this 1. By this 1. So we have what?
1.
1.
So you subtract. Sorry. So
So
you
you
subtract.
get negative 6.
You subtract this 1 from this. Then write it beneath here. We have this one. So we will subtract. We will add. Sorry. So we are adding the 0 and the 1. We have 1 and 1. So we have 1 here again. Please, do you get what I'm saying?
Yes, please.
Then you multiply this 1 by this 1 again, where we write it here as what? 1. Then you subtract that one. So when you subtract the one, when you subtract this one, when you add this one and the -7, you have -6. Then this one times the -6 will give us -6. Then you subtract, you add the -6 and the +6, which will be 0. These are at this moment. Is everybody getting it?
Yes, please.
Yes.
So with this, then we know that our remainder
0.
Our coefficient will be 1, comma, and then which one? Another one. That is the ones here, comma, -6. So when you are done with that, then you come to you bring that of the s beneath it. So we start from, we have our 1, we have our 1, then -6, which means it will commence from s square since they are 3. Please you get it. So we have s square plus x
-6.
-6.
Please, may I know where the s square is coming from?
So the s square is coming from the coefficients we are having. Now you can see that when you have something like s cubed, the terms, okay, so s cubed, the terms are 4, 1, 2, 3, 4.
Yes, please.
Then with square all the time, the terms are 3. So with this one, since it is 1, 2, 3, then we will have that of s square plus x -6. Am I correct?
Will the 6 become the constant?
The 6 here, the 6 becomes the constant. That is how it is.
Please, so does it mean that after we've done the synthetic to get the 1, -6 and 0, always the last number becomes the remainder?
Yes, please. The last number becomes the remainder.
Thank you.
Hey, hello.
Hello.
You have done well, but the last explanations you are giving, it may confuse somebody sometime to come up.
Hello, madam.
It's correct. What you have done is correct. But realize that you have written remainder equals 0. Remainder equals 0. Yes, and your remainder is 0 from where you are coming from. The 6 -6 gives you 0. Yes, and you have 1, 1 -6 and 0, isn't it? So somebody will say, like, ideally the 0 should have been the remainder. Yeah, the 0 is the remainder. And mostly with the synthetic, the last number is your constant, isn't it?
Yes, madam.
And so if you now say the last number, which is the -6, becomes your constant, I don't understand.
Then it means 0 becomes a constant, madam. I got it.
Yeah, please, can we go back to the notes?
Okay, madam. I'll stop here.
So this what he did is correct. 1 1 -6 and 0. That is what you would get. If you even do the long division, if you do the long division, you're going to get x squared plus x minus 6, with 0 being the remainder. 0 over, yes. But then when you go through the notes again, you realize that the ones in the beginning are your coefficients. Okay, starting from x equals 0x raised to the power 0. Then the last number is your remainder. So in this case, we had the 1 1. We had the 1 1 minus 6 0, isn't it?
Yes, please.
So for this one, sorry, for this one, the answer you're likely to get is 1 1 minus 6 and 0. -6 and 0. So if that is the answer and the last number is your remainder, what's our last number here?
0.
It is 0. Okay. So the remaining 1 1 minus 6 becomes the coefficient of, or in the quotient. So it will become what? 1. I'm just using it. 1 1 minus 6 here. So it's not like that is the that becomes like the constant in the quotient, but the remainder is your, the last number is your, which in this case was 0. So this is a remainder. So we have, yeah, I think so. What you are doing is x squared minus plus x minus, yes. So you have x squared plus x minus 6. Oh, I can't do that. So you get this. So this becomes your quotient. This becomes your quotient plus 0 over the divisor, and that is still 0. So this is the actual answer that you get for the first one. Now the second one, what did you get?
We are about to get to that one. But
Oh, really?
we had a square minus 4. And the remainder was
Won't you get 1
1
1
0 minus 4.
Madam, please,
Yes.
we had 1 0 minus 4 0.
0, yes. And that 0 here is the remainder. So it will be like the first case. You don't even write it. Yes, and then so you have what? X squared minus 4. Minus 4. I like it. X squared minus 4. Now, if you want to write it with what is here, then that's where you go ahead and do the plus 0x. Plus 0x. But then, like I said, no good mathematician does that. So it goes on to tell you that whether you use the synthetic method or the long division, you will end up with the same thing. So this was what we got in addition to this that we have explained since morning.
Madam,
No.
please, I hope you will not be restricted to using a particular method.
Oh, no. It's a long division. It's a long division. So the question is likely like what you have. Find the zeros and sketch. Whichever way you use to find the zeros, that's fine. And it would be like but then what if the question wants to be strict? Using the synthetic method.
That's where the problem comes.
So
But it's a free world. They should allow us.
It's dependent on the question. It's dependent on the question. But for me, all of them are quite easy. Except that I feel the synthetic is quite simple. Let's write all the coefficients and please be mindful. Do the arrangement first. Though maybe you didn't state it in the synthetic method, do the arrangement first. Write all the coefficients down. Bring your C to the left and then start doing your multiply, add. You're done. But then if you are doing like find the zeros, whichever method that you're okay with, you can go ahead. Somebody used a long division and he arrived at the answer. Okay, so we are moving on to rational expressions. These ones, we know them, so I'll quickly run through it so that we do the number basis. A quotient of two algebraic expressions is called fractional expression. So these are examples of fractional expressions. A rational expression is a fraction expression where both the numerator and denominator are polynomials. Rational expressions are also functions. So all these are rational or fractional expressions. We can perform the standard algebraic operations such as addition, subtraction, multiplication, division on rational expressions. We can determine the domain as well as simplify and factorize them, just as we do with those involving real numbers. The domain of an algebraic expression is a set of real numbers that the variable is permitted to have. This one, I said it when we were doing in that lecture 2 or so. The domain of an expression. So what is the domain of A? What is the domain of A? What is the domain of A? So I'll do the first one. The domain of A is a set of real numbers. The domain of A is a set of real numbers. The domain of B. What is the domain of B? So the domain of B is the set of real numbers except X.
Except when x is equal to 3 and x is equal to 2.
Yes. Yes. So I told you the domain is what is allowed, what is permissible. If you take the A, for instance, all numbers are allowed. Nothing is not permissible in mathematics. All numbers are allowed in the first one. When we pick B, you are not supposed to divide by 0. It is not allowed in mathematics. So every number is allowed except when a number will make the denominator run to 0. It is not allowed. So the domain of it, and when you put x equals minus 3, this will be 0. X equals minus 2 can make the denominator 0. So these two numbers I just did the factorization in my head. But these two numbers, if you put them in the denominator, if x is equal to these two numbers, it is not allowed in maths. So a set of real numbers, comma, x is not equal to -3, x is not equal to -2. Okay. So the last one is what?
Madam.
Yes.
Please, can you go back to the B again?
So B, the B, if I put x equals 2, what would the denominator be? I'll get 4 minus 10 plus 6. And this will make the denominator 0 if x is equal to 2. Isn't it? If I put x2 equals to 2 in there, what if I put x equals -2? -2, the first one will give me 4. The next one will give me 10 plus 10 plus 6. It is 20. So -2 is okay. -2 is allowed. But when it is 2, positive 2, the denominator will be 0. Let's look at 3, -3. -3, the first one will give me 9. -3, then this will give me -15. You know, positive 15, isn't it? Let's use positive 3, positive 3, positive 3. So I'll get 9 minus 15 plus 6, and this will be 0. A positive 3. Positive 3, I'll get 9 minus 15 plus 6, and that will give me 0. But if it is -3, -3 will give me 9 plus 15 minus 6, which is plus 6, which is a different number, and that's okay. So these two numbers, exactly. So these two numbers, 2 and 3, 2 and 3, 2 and 3 is not allowed. So you can say the set of all real numbers, except that x should not be equal to 2, x should not be equal to 3. That is the domain for B. The last one, C. What is the domain for C?
The last one, x is equals to all real numbers, except x is less than 0 and x is not equal, and s is equals to 5.
Exactly. Exactly. So he said that the domain is a set of real numbers, except x is not less than 0 and x is not equal to 5. These two conditions, if you permit it, it will not make the whole thing permissible. We can't get the square root of a negative number. That is why he made the first condition. X should not be less than 0. Then the second one, x should not be equal to 5. Satisfy the denominator. If it is 5, the denominator will be 0. And it is not allowed. So that is the domain for C. So that is why in here he says the domain of an algebraic expression is a set of real numbers that the variable is permitted to have. That is the domain. So if there are exceptions, you state the exceptions. So this one is permitted to have any other, whether negative or positive, any fractions, they are permitted. Here, the top one, any, is okay. But down there, there are some numbers that will not be permitted, which is 2 and 3. Then for the C part, the numerator is not permitted to be negative. The denominator 5 is not allowed. So that is the domain of expressions. Now let's come to simplifying rational expressions. To simplify rational expression, we factor both the numerator and denominator and use the following property. So if you have AC over BC and you have to simplify, the C up there cancels the C down there. and then you're left with A over B. So you have this expression to simplify: x squared minus 1 all over x squared plus x minus 2. So both the numerator and denominator are of the same degree quadratic expression. We cannot cancel out x squared because it is not a common factor. So the numerator can be simplified as this. If you remember, x squared minus 4. X squared minus 4 is the same thing that is happening here. So x minus 1, x plus 1. And the denominator, also you can simplify it as this. Can simplify it as that. So now that you have done the two, the numerator and the denominator, you can see some common between them, common terms between them. Then you cancel out those terms, and then you end up with x plus 1, x plus 2 as the denominator. So you factor out the common ones, and then you cancel out each other. That is how to simplify such expressions. Please, I hope it is clear.
Yes, please.
Okay. Then we come to multiplying them. If you have A over B multiplying C over D, how do you simplify? Or how do you solve them? What you do is multiply the numerators and multiply the denominators together. Very simple. Very simple. So A over B multiplying C over D, what you get is AC over BD. So we have this expression. It's coming soon. Okay. So we have multiplied this by that. Multiply this by that. So for the top one, this is it over there, multiplying this. So I guess what happened was you factorize the top one, multiply it by what is here, the down one multiplying what is here. Yeah, so it did a factorization of that, and that is what we have here. And this is what we have here. Then multiplied by the same, it did a factor out of the 3, x plus 4, x minus 1. Now having this, it went ahead to 3. So you have this. If it's you could just multiply all the top one and all the down one, but then it did some kind of cancellations using the first method as well. If you have the two, if the numerator and the denominator have something in common, you can cancel out. So you realize that this can cancel out this one. This expression at the top here can cancel out this expression here. And then x plus 4 all squared, one of them is here. So this one can cancel one of this. So you are left with just the 3 plus x, and then there's 3 here. Then the down here, this one is already gone. So one of this remains. So the 3 is here, the x plus 3 is here. Then the remaining x plus 4 here. How we got here is how I'm explaining. This x minus 1 cancelled out this x minus 1. This x plus 4 cancelled out one of this. So at the top, the numerator, we have 3 multiplying 3x plus 3. And that is what we have here. And then the remaining x plus 4 is also down here. So this is what we have over here. But then if not, you can multiply all the numerators, multiply all the denominators. But then when you do that and you leave it, you have not simplified, meaning you can go down further. Then to divide, but the rule is saying that if you have this multiplying this, multiply all the numerators, multiply all the denominators, but make sure that it is in its simplified form, because the A and the B can have things in common that you can cancel out. So that is just what happened over here. Then we have division, to divide rational expressions. How do we do that? If you have AB dividing CD, to solve that, you change it into multiplication. Now, when the sign changes to multiplication, the divisor, so in this case, this divided by this, the divisor would swap places. The numerator and the denominator of the divisor swap places. So it becomes a D over C rather. AB remains the same. Division changes to multiplication. And then in the divisor, the numerator becomes the denominator becomes the numerator. That is how we do it. So we have an example here. Is just the rules that we are following. So this example here, you have AB divided by CD. So in that case, you realize that AB still remains the way it is. Then multiplication in place of the division. Then the denominator becomes the numerator. The numerator becomes the denominator. And then you solve it like doing the multiplication. So if you should expand what is up here, possibly this is what you get. Then the down here, possibly this is what you get. Then if there are any like terms in the numerator and the denominator, they cancel out. They cancel out. Then you end up with what you have here in its simplified form. In its simplified form. So that is how to do the division. Move on to subtracting and adding. To add or subtract rational numbers.
Madam,
Hello.
Madam, please, can you share your previous exams? I mean, the first one, not this one. This one. Yeah, madam, please, how did the person go to 3x plus 12? Because if you have to do the calculation, you're going to get 3 multiplying the x, which is 3x, and 3 multiplying 3, which is 9. But here we have 12. I don't know if you can help me with that.
Wait, this is the question. That is the question. This first one is a question. You have AB multiplying CD. That is the question.
Oh, okay. I think that was where I got lost.
Okay, so that is the question here.
Thank you.
All right. So to add or subtract, we have been doing this from beginning. You have A over C plus B over C. How do you add them? If it is simple like this, you just add the numerators all over the denominator because it is common between them. So like you have 1 over 2 plus 1 over 2. You get 2 over 2. That is very simple. But when the denominators are not the same, you look for the least common multiple. So I have something like 1 over 4 plus 1 over 8. You see, they are not the same. So you can't just add the top 1 plus 1 so that it will give you 2 over what? Here, the rule is CC. So if it was 1 over 4 plus another 1 over 4, then I'm getting 2 over 4. I'll simplify further 1 over 2, that's fine. But then if the denominators are the same, that's why you can just add the top. A plus B all over C. But in most cases, we don't get it like that. You get the denominator different. But then when you carefully look at it, you can have a least common multiple. A least common multiple. So my example was I have 1 over 4 plus 1 over 8. The least common multiple among them is 8. And then 4 divided by 4 will go into 8 2 times, multiplied by the 1, you get 2 plus 1. So 1 over 4 plus 1 over 8, you are likely to get 3 over 8. 3 over 8, meaning you put it in this form and then you add the ones at the top. So that is how to add. So we have this 2. We want to add 3 over x minus 1 plus x over x plus 2. So with this, you realize that they are not the same. So if you can't find the least common multiple, just put them together, like in this example. Put them together, like in this example. And then what you do is x will cancel out, x minus 1 will cancel out one of the x minus 1. Then you multiply the remainder with the 3 there. So I have 3x plus 2. So the least common multiple was the 2 of them because they are not the same. It's the 2 of them. So I brought all the 2 of them down. Now to solve this first part, this x minus 1 will cancel out this one, remaining this, and then you multiply it by the 3, and that is what we have here. When you come to this side, the x plus 2 cancels out the x plus 2, remaining the x minus 1, and it multiplies the numerator, and that's what we have here. Now you have put this in the form that was shown, a over c, b over c. So now you can just put the 2 up there together like this. You can add them together because now they are of the same, the divisor is the same. So you can put the 2 up there together. So now putting them together, I have 3x plus 6 plus x squared minus 1 doing, so we put them together like this, and this is what you have. This is what you have. So the x squared comes 3x minus x is 2x, then the 6 came. And that is it. The B, solution for the B, you go through the same procedure. Go through the same procedure. So x squared minus 1, x plus 1 all squared. So the difference of 2 squares, I think this is, so then for this as well, if you like, put all the 2 of them together, x squared minus 1, then x plus 1 all squared, put them together as the numerator, the denominator, common between them, and see which ones can cancel out which one. So if you take this, for instance, this will cancel one of them. You have 1 multiplying whatever comes here. Then for the 2 parts, this x plus 1 all squared will cancel that one. Then you have 2 multiplied by x squared minus 1. But then for this example, I think it did a simplification. It did a simplification of the squares down here. So you get a least common multiple from them. And then you can go ahead and so we ended up with x minus 1, x plus 1 all squared. So just like that's because it is, it's 2x. Okay, so this gave us that over there. So x squared minus 1, this is it, and then this remains the same. So then bringing all of them together, you realize that in this x plus 1, you can get this. So you don't write x plus 1 all cube unless you want to go ahead with that, but that's fine. But this x plus 1 is also in this. So he just wrote this and then that's 1 over here. Then this will cancel this. Then one of them is already in there. So you have your what? X plus 1 up here. Then this 2 all cancel that. So you have 2, then x minus 1 over here. Yes. So simplifying this, you have x plus 1 minus 2x plus 2 all over whatever is here. X would, okay, so this gives us x minus 2x will give us minus x, then 1 plus 2 is 3. So you have 3 minus x all over the denominator over there. So if you are going to, what happened over here, I'm going over again. What happened over here is, yes, x minus 1, x plus 1, which is the, I think, the expanded version, or having the factorization of s squared minus 1, just like our s squared minus 4. So you get that this was the same. But to find the least common multiple between the two, x minus 1 is in here. So it didn't repeat it. It just brought down the x minus 1 and this. That is the denominator here. Now, if I'm to handle this side, this will cancel out this. This one will cancel out one of this, remaining one, and that multiply the top. That is what we have here. When it comes to this side, this whole thing cancels out that, remaining the x minus 1, and it multiplies the 2, and that is what we have here. The rest are simplification to arrive at this answer. So we have laws of exponents and radicals. Exponents and radicals. So here we have rules that govern, just like where we are coming from. Rules that governs this exponents and fractions. So it's saying that, you know, any number raised to the power 0 is 1. And then we have any number raised to a negative exponent. You can have it as 1 over the number raised to its exponent. We have removed the negative exponent from there. So with this, we have many rules or laws. We call some of them laws of exponents, laws of indices. All these are there. And it says, well, they are taught in secondary schools or high schools. So these rules, if you see somebody using it, it is not how did the person get this. It's a rule. It's a rule that is aiding the person to get that. So for these examples that we are looking at, you realize it is using the rules that exist. So I have 4 over 7 exponent 0. No matter the number, if your exponent is 0, you equate to 1. Now we have x exponent minus 1. This will give us 1 over x exponent 1, positive 1, which gives us 1 over x. So this is how to get rid of negative exponents. So when you have minus 2 exponent minus 3, the first thing, 1 over minus 2 all cube, because then you get rid of this negative exponent. You have 1 over 8 is the same as minus 1 over 8. So there are many rules. Maybe some of them you, as a refresher course, you can refresh yourself on that. Some of them may be new to you. So if you have AM multiplying another AN, the bases are the same. You can multiply you can add the indices. You get AM plus N. If you are doing a division rather, which is AM divided by A to exponent N, what you do is you can subtract the exponent. A is equal to M minus N. If you have it of this form, AM all into brackets exponent N, you can multiply the exponents. 1 over AN is like going back to getting the negative exponent to get A minus N. Then if you have A exponent 1 over N, that's N square root A. So if you have like a cube root, that means it is the base exponent 1 over 3. If it is the root has a number in there, it is the base raised to the power 1 over that number. That is what it is trying. There are more rules over here. So these rules are what you use when a question is asked. And these are the laws of exponents as well. Some of them we see it. So we have an example, x4 multiplying x7. One of the rules say just add the exponent. So this is what you get. You have y4 y exponent minus 7. How do you solve this? Just add, because they are of the same basis, just add the exponents. And then you have y minus 3. But then you can have one of the rules says if you have this and you want to get rid of the negative exponent, you get 1 over y exponent 3. C, you have C9 all over C exponent 5. You can subtract their exponents. C is equal to 9 minus 5. You end up C4. D, B4 all exponent 5. Multiply the exponent. So you end up getting B exponent 20. And the rules are here. 3x cubed. You can multiply through. If you want to open the bracket, multiply through. So you have 3 cubed x cubed. And this is what you get. And this we have been doing it. That's why I don't want to waste much time on this. This is something that we have been doing when we say simplify. X over 2 all raised to the power 5. X raised to the power 5 all over 2 raised to the power 5. And you can simplify further. Now, these are more exercises that you can try your hands on. And all these, I picked it from your notes. All this, I picked it from your notes. So I don't know if there are answers there, but then when you solve them, you can put it on the platform asking me if it is correct or not, or you are in doubt of something. And this is further exercise for you to try your hands on. I think this was solved here. That's the solution here. And the question is saying eliminate the negative exponent and simplify. Eliminate the negative exponent. And there's a rule that should guide you how to eliminate the exponent. So we have 6st minus 4, 2s minus 2t squared. So then with this, for instance, the t can come down, the s can go up. Now, if the t comes down, you realize that it will be t positive 4, raised to the power positive 4. And if the s goes up, it will be s positive 2. So should you solve all of them together, you would get 3s cubed over 6 over t exponent 2. So this 2 divided this, that's how the 3 is there. Now, where did this s cubed come from? Look at the question, you realize that s is 1 here, and this is minus 2 here. So if it goes up, you have s exponent 1 multiplying another s positive 2. And if the bases are the same, you add. So 1 plus 2 gave us the s3. Now, if you look at the 2, yes.
Madam,
Hello.
please, is it always that the first letter will have to go up, or the second? I can also shift to the second letter.
You can bring it down. You can bring it down. It's not like go up. It's your own. You can decide to bring the s down and the t goes up, or whichever way.
Okay.
Whichever way.
Thank you, but there is one thing I would like to do for me. That one, it's my network. It's spoiled. That is the synthetic aspect. That one, when you were teaching, my network went off. So if you can help
The
me with that,
recording is
only
there.
that area.
I will help you. But if I'm done with my
Yeah,
last
only
lecture,
that area.
I hear. If I am done, don't worry. I'm done with my last lecture, and there's still time. I'll go over the synthetic for you. All right. So now the T1 2, he brought the T1 down, and you realize that it will be what? Positive 4 down. So 4 plus 2, that's what gave us the T6 here. So it's all about applying the rules that exist there to find a way out. Okay, so the B part 2, you realize that if you are to remove the bracket, you'll be getting what? Y exponent minus 2, 3 exponent minus 2, z exponent 3 multiplying minus 2, and then you simplify them together. But so we apply law 6, which allows the change of signs of the exponent of a fraction by inverting the fraction. So one of the laws says that if you want to get rid of this, change, and the inside there is a fraction. When you swap it, the sign for the exponent will change. So in here, because we wanted to make this positive, we swap what is inside. So the numerator becomes the denominator, numerator, numerator, denominator. It changes here. And then we can go ahead and open the bracket 9z 6 and then y squared. And then you have it like that. So in short, just apply the rules. Just apply the rules, and then we are good to go. I think this is it. So a over b all negative. You can do b over a, and then the rule, the negative goes away. You apply the rules, and that is it. So let's take like 3 minutes break, and then let's start with the last lecture. That is number basis, and this is very simple. Convert from this to that, from that to that. It is very simple. You should use the rest of the time to do this one. So 2 minutes. According to my watch, it is 10:12. We will reconvene 10:14. Just a very short break. A very, very short break. Thank you.
Madam, we are going and we will be back, right?
Pardon? Yeah,
We
after
are
the break,
going
we'll
and
do
coming back.
this. Yes, 2 minutes, 2 minutes.
And then we are coming to do the hexadecimal.
Yes, 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 yes. But it's very simple, so we will finish. It's very simple. It's just conversion. We'll finish very soon.
Okay,
All right,
okay,
so
madam. So we are coming back 10:20.
okay, you let's say 10:20. 10:20, you reconvene. It's okay. 10:20 is okay. All right, so according to my watch, it is 10:20. So we are continuing. All right, so for binary numbers, these are numbers that uses only 2 digits, 0 and 1. Then we have the decimal numbers, are numbers from 0 to 9. All other numbers are a combination of the 0 to 9. That is the decimal number system. Then binary is they have only 2 digits, or the base is 2 and the digits are 0 to 1. So mostly any number, when they say base 4, that means it's up to 3. Base 5 meaning it's up to 4. That's how all the numbers mostly are. So the first conversion that we are going to look at, so the whole process is convert from this to that, from that to this. How do we do it? If they give you an example or a question, convert from this base to another base, what do you do? So that is all what we are going to do. So if you look at the outline, it's a conversion from decimal to binary via octal. We look at hexadecimal, conversion from decimal to hex, binary to hex. So this is just what we are going to do, conversion from one base to the other. And mostly because we are concentrating on the computer numbering system, it's not all the numbers, but mostly octal, hexadecimal, decimal, binary. These are what we are going to convert from or to and from. So the first one is conversion from binary to decimal. From binary to decimal. Please, are you there?
Yes, madam.
Yes, madam.
Okay. So from
We are
binary
here.
to here. So from binary to decimal, we have
Hey,
this.
Doc, it seems you are done with 2 slides.
Oh, there's nothing there. There's nothing there. We are now doing the conversion.
Okay.
So the conversion mostly to, I wouldn't say, but mostly when you want to convert to decimal, this is the process. To decimal, this is the process. So you pick the number. This already is in decimal, and we are converting it to decimal. So we want the decimal equivalent of 234.5. So you pick the number, multiply it by the base of where you want to convert to. Now you want to convert it to decimal. So the base is 10. So you pick each and every digit, multiply by 10, raised to an exponent. And the exponent starts from 0, 1, 2, going on. So if there was a number in front of 2, that would have multiply 10 exponent 3. That is how it goes. Now, if there's a decimal point, after those ones, the exponents are negatives. Those ones, the exponents are negatives. So having 234.5, the 0 will start from the last before the decimal point. So 4 has the exponent of 0, 3 has the times 10 exponent 1, 2 will have times 10 exponent 2. If there was a number that will have times 10 exponent 3, on and on. But after the decimal, the exponent starts from -1. If there's another number after 5, that will have what? -2. Another number, -3. And then when you finish, you add all of them together, and that will give you the decimal equivalent. So you realize that this will give us what's number 200, isn't it?
Yes, please.
And this will give us 30. This will give us 30. This will give us 4. So you get 234, like you are seeing here. Then this is like well, what do we get? 1/10. 1/10 multiplied by 5, you get what? 0.5. It's like half. That is what you see there. So that's how mostly to convert from. We just converted from decimal to decimal. But if you have it if you have the question in binary, this is the same procedure you would use. So we have a question here. We want to convert 1101.1 to decimal. Now this is in the binary. If a question is asked that converts this binary to decimal, it is wrong, because this cannot be a binary number. Binary numbers are 2-digit zeros and ones. So now we have a question here. Convert this binary to decimal. So what you do is you pick each of the numbers, multiply by 2, because the number is in base 2 and you want to convert to decimal. So that is the base. So you pick each and every digit like that, like what we did for the decimal, and you multiply each digit by that base to the exponent. Please, I am getting feedback. So I have the first one multiplied by 2 exponent 3. If you are not too sure, please start from the back so that you know which exponent is appropriate. So starting from the back, this is 0, 1, 2, 3. That's how we have 2 exponent 3. 1 times 2 exponents 2, 0, this 0, multiplied by 2 exponent 1. Then the last one, multiplied by 2 exponent 0. Negative, you treat it as such. 1 times 2 exponent negative 1. So when you do, you simplify all of them. 1 times 2 exponent 3 gives you 8. 1 times 2 exponent 2 gives you 4. 0, doesn't matter, don't even solve for 0. 1 times 1 is 1, then the half will come. And the half, then you go ahead and solve for it. So you get 13.5. You put them all together, you get 13.5. We have another one. Convert 11011 to decimal. So the base of it is what? 2. So you pick each and every one of them, multiply by the 2, which is the base of where you are coming from, exponent, depending on the placement. So if I start from the back, the exponent will be 0, 1, 2, 3, 4. So 1 times 2 exponent 4, 1 times 2 exponent 3, 0 times 2, 2, 1 times 2, 1, 1 times 2, 0. Then you simplify and solve, and then you end up getting what? So this is 24. Exactly, this is 27, the 27. Yeah. So you end up getting 27 in base 10. 27 in base 10. So this is how to convert from binary to decimal. You do a multiplication, but don't forget the exponent. If it is a negative, if it is after the decimal point, to know how to handle it. So there's another example. You want to convert 0.1011 in base 2 to decimal. So what do? You see that the first one is 0, so we don't even care about it. It would come anyway. But the next is 1 times 2 exponent negative 1. Then 0 times 2, negative 2, negative 3, negative 4. You solve for all of them, and then you solve for all of them, and then you get 0.6875. 0.6875. So if 0 is a starting, we know it will still be 0. The rest are after the decimal points. You solve for that, and that is it. So we have another example. Convert from binary to decimal, and the first part before the decimal point, those ones are positive exponents, starting from 0 from the back. So the one at the back gets 2, 0. the middle 0, 1, the first one is 2. Then after the decimal points, all of them are -1, -2, -3, -4, just like what we have been doing. When you finish, put all of them together, but don't forget where the decimal is starting from. And don't forget where the decimal is starting from. So we have 5 points, the rest. Then you put them together, and you have 5.3125 in base 10. So that is it. So these are more exercises that you can do on your own. Convert the following binary numbers to decimal. Convert the following binary numbers to decimal. So this you can try your hands on. If you want to verify, please, after solving, you can put it on the platform and ask if they also got the same thing. If anybody solves it, I'm sure they'll reply. If I see it, I will reply. So these are exercises for you. Convert from binary to decimal. Don't forget, if there's a decimal, the exponents are negatives. So that is it. Now we want to convert from decimal to binary. Decimal to binary. We have been converting from binary to decimal. Now we want to convert from decimal to binary. Any integer decimal can be converted to a corresponding binary number by repeatedly dividing the number by 2 and noting the remainder at each stage until there's no more a remainder. The result is obtained by arranging the remainders or writing remainders from the last remainders as the first or most significant bit, in that order until the first remainder becomes the last bit or the least significant. The last remainder is the most significant bit. I know from lecture 1 or so, you know what the most significant bit is, you know what the least bit is. And then we'll go to anyway. So we have an example, convert 39, which is in base 10, to a binary number. It is saying that you can achieve this by repeatedly dividing the number and noting down the remainders. So we have 39, we divide by 2, it is 19, remainder 1, meaning that when you multiply these two, you are likely to get 38, and the remainder is 1. When you take 19 and divide by 2, we get 9, remainder 1. 9 times 2 is 18. The remainder is 1. 9 divided by 2, we get 4, remainder 1. 4, remainder 1. 4 divided by 2, we get 2, remainder 0. 2 divided by 2 is 1, remainder 0. Now, 1 divided by 2. We can't even go inside, so you just bring the remainder down there. It is 0, remainder 1. We will not go inside. So it's 0, remainder 1. You can look at it from that direction too. So this is the remainder that you get, and that is where your answer is coming from. Now, where the most significant, the least came in, it is all that English is saying is, when you are writing your answer, start from the down, up. Start from the down, up. So you get 1, 0, 0, 1, 1, 1 base 2, and that is your answer. Don't start from the top. Start from the down part, upwards. So the last one here becomes the most significant bit. And then towards here is the least significant bit. So we have converted from decimal to binary. We have another example. Convert 47, which is in base 10, to binary. What we do is to divide repeatedly by 2. We are by 2 because 2 is the base for binary. If it was octal, then you divide by 8. If it was hexadecimal, then divide by 16. So when we say divide by 2, the 2 is not coming from anywhere but from the base of that number system, which is binary. So this example here, convert 47 in base 10 to binary. You divide repeatedly by 2. So 47 divided by 2 is 23, remainder 1. because you get something like 46 if you should multiply remainder 1. 23 divided by 2 is 11 remainder 1. 11 divided by 2 is 5 remainder 1. 5 divided by 2 is 2 remainder 1. 2 divided by 2 is 1 remainder 0. And 1 divided by 2 is 0 remainder 1. So when you get this, you write it from the down part. 1 0 1 1 1 1, and that becomes your answer in base 2.
So please, madam.
Yes.
So the base 10 attached to the 47 has nothing to do with the
It is
binary,
telling
right?
you the no, it's telling you the base. That is why it's a subscript. It is telling you the base in which that number is. It's just like the answer. When you see the answer, you see a 2 here. You see a 2 here.
Okay.
The 2 is telling you, those numbers are telling you the base in which the number is in. So the 10 is telling you the 47 is in base 10. And you have to convert it to base 2.
Oh, okay.
All right.
All right. Yeah.
Okay, so we are moving on to another example. And this example says convert 0.625 in base 10 to binary or to base 2. Now, because it's after the decimal point, handling it is a bit different. It's a bit different. So how do we do this? Instead of the division, here you do the multiplication rather. Instead of doing the division. So if it was before the decimal point, you do the division repeatedly. But if there's a fraction part after the decimal, you do a multiplication of that part alone. So we have 0.625 multiplying 2, and you get this. And you get this. Now, what we note down is what we get before, after multiplication, what we get before the decimal point, and that is 1. Then you pick the fraction part of what you got, multiply again by 2, you get another number, 0.500. The whole number, like let me put it down, the whole number before the decimal point is what we note down. Then the rest of it, once it is not up to 0, where you not get anything, you keep doing that repeatedly. You pick the next, the 0.500, multiply by 2, you get another number. Note down what comes before it, and the rest is 0. Now, if you continue, it is 0, 0, 0. So until the fraction part becomes 0, you continue doing the multiplication like that. So at this point, it is 0. So we can stop here. Now we have 101. Now the most significant bit, 101, least significant bit, it's arranged from the first to the last. So instead of what we're doing for the before the decimal point, here you start from the top down. If it has a fraction part, you start from the top down instead of the bottom up. Now, because this is 101, you don't see it well. Let's take this one. This example again. You have to convert this into the binary. So you start with that number 0.40625 multiplied by 2. You get a certain number. We note down for the decimal points down, which is 0. Then you take the 8125 parts down, you multiply by 0. That is here. You multiply by 2, sorry. You get another number. Note the whole part down, which is 1. The rest, you take it, multiply by 2. You get a number. Note the whole part down. The rest, or the fraction part, take it on, multiply by 2. You get another number. Note the whole part down, which is 0. The fraction part, you take it down, multiply by 2. You get something. Now here, since they are all 0, you stop. But note the whole part down. Now your answer is from the top down, not down up, like what we were doing for if it was 47 base 10. So your answer that you get is 0.01101 in base 2. 01101. So if it is a fraction part, it's top down, but if it's a whole part, it's bottom up. Don't forget. So we have another example. Convert 58.3125 to base 10. Convert it to base 10. So the 50, you have to solve the 58 part and the 3125 part, because the process is different. So the 58 part, you do the repeat division. You do the repeat division. How do you get your answer? From bottom up. 111010. 111010. That is for the 58 part. And then you go on to the 0.3125 parts where you do your multiplications. So you do your multiplication, be noting the whole numbers down. You take the rest, go on to do the multiplication, whole number down, the rest, multiplication, whole number down, the rest, like that. And now you start from what? The top, 0101. Now you add all of them together, and that will give you what your conversion. So this is coming as a result of what we did earlier on. This one, 111010. That is the first part here. Then 0101 is a fraction part. We have converted 58.3125 into base 2. So here too we have exercises. We have exercises to try your hands on. Because of time, we will not go through. If I finish and there's time, we can do some of these exercises. So it is there for you to try your hands on. Like I've said, if you try your hands on and you put it out there to ask whether it is correct or not, for me, I will answer. Now we want to convert from decimal to binary via octal. Octal is base 8. Octal is base 8. So for decimal integers containing several digits, doing the division repeatedly can be a lengthy process. In this case, it is usually easier to convert the decimal to octal before binary. This system has a base of 8 using the digits 0 through to 7. So let's see how this is done. Oh. I think my screenshots covered the question. So the question four, 3, 1, 7. We want to convert it to base 8. We want to convert the direct number equivalent of the octal number 431 is this. So okay, we have this number in octal and we want to convert it to decimal. So what do? We realize when we're converting even decimal to decimal, this is the process. Each digit multiplied by the base of that number exponent the position where it is. So 4 by 8 exponents 0, 1, 2, 3. Yes, 3, 8, 2, 1, 8, 1. Then last one 7, 8, 0. Then you solve for it. This is the decimal equivalent of this number. The decimal equivalent of this number. Now it's saying that any integer decimal can be converted to a corresponding octal by repeatedly dividing by 8 and noting the remainder. So if you have it in decimal and you want to put it into octal, now instead of a division by 2, we divide by 8. We divide by 8. So we have this and we want this in decimal. We want to convert, our aim is to convert from decimal to binary, but through octal. So the number is given in decimal, we want to convert to binary, but you have to go through octal. So we want to convert 493 to octal. It says what? Do divided by 8 repeatedly, like when we were converting from decimal to binary, divided by 2 repeatedly. By saying that sometimes if the number is big, your table can be long. So it is appropriate to go through the octal way rather. So You take the number 493 divided by 8, you get 61, remainder 5. 61 divided by 8, 7, remainder 5. Now 7 divided by 8 is 0, remainder 7. So 493 in base 10 is 755. From the down, it is no fraction. So from the down, 755 in base 8. 755 in base 8. So that is how to convert from decimal to octal. Repeatedly divide by 8. Now, if there is a fraction part, then you do the same thing, but this one, it is multiplied by 8, not 2. So you bring that fraction down, multiply by 8, you note the whole part down, take the fraction part, move on and multiply till that the fraction part is 0. So now we have 3, 4. We have 3, 4, which is the octal of this fraction. Here. So this table says that the natural number code for digits 0 to 7 is shown in the table below, and an octal number can be converted to a binary by writing down the 3 bits corresponding to the octal. So it is saying that these numbers from 0 to 7, which is the octal, this is a binary number for it. This is the binary number for it. So if you have, let's say, 26.35 in octal, it is simple to take it into binary by taking each digit and replacing it with the numbers here. So 2 is what? 2 is 010, but you have just 10 here, because a leading 0, mostly you don't write it. A leading 0, mostly you don't write it. So that is it. Then the next one is 6. 6 in binary is 110. So that is what we have here, 110. Then your decimal point will come. Then 3, 5, what is 3? 3 is 011. So you have 011. Then 5 is 101. It's 5101. Yes, 5 is 101. Then write it here. You have converted from octal to decimal. To binary. Octal to binary. So after converting from decimal to octal, you look up in this table and then you convert back. Now this table, even if in an exam it is not given, you can draw the table yourself. What is happening here? 0 is all zeros. 1 is just 1 from the least side. 2, because 2, you don't write 2 in binary. So it's like you do a +1, and then this side becomes 2, carry forward 1. So the 1 comes here, this is 0. 3, you add another 1 to get 011. So it's just like addition, but now you are adding in base 2. And base 2, the numbers are just 0 and 1. So if you have 1 + 1 giving you 2, don't write the 2. You write the remainder, which is 0, carry forward 1. That is how it is done in base 2. And I think this, either in JSS or SS, we were taught this. So that is it. So now, if you have the table here, just look up the table and replace the digits with the equivalent binary numbers. So 26.35 is 010. If you still want to bring the 0, 010, 110.011, 101 base 2. Like I said, you can omit the leading zeros. So we have an example. We want to convert 3714 base 10 to binary via octal. So we convert first to octal and then to binary. So 37.14, we divide by 8 repeatedly. Divide by 8 repeatedly, and what we end up getting from down up, don't forget, 7202. That is 8 equivalent in octal. Now looking up the table, we replace each and every one of them. So what is 7 in octal? 7 is 111. So you can see 111 over here. The next number is 2, which is 010. If you can remember, 0102. So 010. Another 2 is there, which is the 010. Then 0 is all zeros, which is here. So just look at the table and then you put in the equivalent binary number there. You have converted from decimal 3714 base 10 to this long thing base 2. If you were to do it straight away, the table here will be very long. Not like you can do it, you cannot do it straight away. You can do it straight away, but the table here will be long because you'll be dividing by 2. So even if this is still confusing, do your own way of doing the division by 2. You'll end up in the binary. Now we have convert this 0.59375 binary, no, decimal to binary via octal. Now there's a fraction part. So we do a multiplication. Multiply the fraction by 8, you end up getting this. Note the whole number, carry forward the next, and then do the multiplication again. You end up getting 6.000. Note the whole part down. Since the rest is 000, we stop there. And then it is top down, not bottom up. Top down. So you get what? 0.46 in base 8. Then you look at the table and then you put them. So what is 4? 4 is 100. 4 is 100. So we have what? 100 for the 4. And 6 is 110. 6 is 110. We have our base 2. Our base 2, very simple. Now, still more examples. We want to convert 5613.90625 base 10 to a binary through octal. So we take the whole part and divide repeatedly by 8. We get a remainder, and then we have from bottom up 12755 in octal. Then we do that of the fraction part. The fraction part, remind yourself, we have to multiply, not divide like the whole number. So the fraction part, we do the multiplication, we get 90625. Okay, 90625. We multiply 7.25, whole number down. We take the 2500, bring it down, multiply by 8, we get 2.000. The whole part is 2, so we end here. And then what do we get? We get 0.72 in octal. So the 0.72 in octal, 7 is, I think, 111, isn't it? 111, and 2 is 010 in base 2. So then now the question was, we have the whole part. So this part is what we have here. The 0.96 in base 10 is what we have here. This is in base 2. Now we need to add the whole part number to it. And what do we do? Since we have it in base 8 as 12755, we place it by the zeros. So the digits here are what? 1, 2, 3, 4, 5. So 1, 2, 3, 4, and 5. So that is coming from 1, 2. So if you can see 2, 1 is just 001. So we remove the leading zeros, which is just 1. The 2 is 010. 7 is 111. And I think what again? 5 is 101, 101. There are 2 5s, 101, 10. So we just put them together, and then you add the fraction parts, and that is it. Now, what if you have it's in binary and you want to convert it to decimal via octal. You have it in binary, convert it to decimal via octal. So the question is given this, convert it to decimal via the octal. What do you do? The numbers are there. So you realize that from when you convert the decimal from decimal to binary via octal, we have the question in decimal, we convert it to octal. Then how do we get the binary? We just do a lookup. So this is just a reverse of what we did. So if you have it in binary, we have to convert it to octal, then octal to decimal. Now we have this question, meaning that we need to use the lookup table and then convert these numbers into octal. So 011 is 011 is 3, that is what we have here. 110 is 6, that's what we have here. Then the last one, 011. 011 is 3, so we have 363. And when we come to 4, 4 is 100. So we put 4 there. Then 010 is 2. So just looking up the table, we convert from the binary to the octal. And then now we have to convert this octal to decimal. We have to convert it to decimal. Now I say the decimal is the times 1, this one. So mostly, let this always be in your head. Even decimal to decimal is the same process. This, what we started with. So having this in octal, 3 multiplied by the base in which the number is in, exponent, where it is placed. So the last three here has an exponent of 0, 1, 2. So 8 exponent 2. 6 times 8 exponent 1. 3 times 8 exponent 0. After the decimal, it changes to -1 onwards. -1, -2. And then you go on, you simplify, you get 243.53125 in base 10. In base 10. In base 10. Now we have hexadecimal numbers. Hexadecimal numbers is where the base is 16. The base is 16. So the complexity of computers nowadays requires higher order numbering systems such as octal and hexadecimal, which are merely extensions of the binary number system. So a hexadecimal numbering system has a base of 16 and uses the following distinct digits. So it has 0 when it gets to 9, it doesn't do 10, 11, 12. The 10 changes to A, 11 B, 12 C, 13 D, 14 E, 15 F. So that is what we have here. So we'll be converting from hex to decimal. To convert from hexadecimal to decimal, we multiply the hexadecimal by the powers of base 16 and find the sum. That is how we convert from hex to decimal. Hex to decimal. From hex to decimal. So we are taking one example. Convert 1A16 to decimal. Once you hear decimal, this process should come to your mind. Multiplication. Raised to the number something. So we have this, we are converting it to decimal. So we pick each and every digit, multiply by the base in which that number is, exponent its placement. So A is at the 0 part and 1 is at the 1 part. So times 16 exponent 0. So we have, this gives us 1 and A is 10. So that's how come A is 10. 16 exponent 1 is 16 multiplied. So all this together I have what? 16 plus 10, 26 base 10. 1A16 in decimal is 26 base 10. Very simple. Very simple. So then we have another example, 2e base 16, and is in decimal. No, is in hex. We want to convert it to decimal. So each and every one of them multiplied by 16 exponent the placement. So 2 times 16 exponent 1, e times 16 exponent 0. You simplify, and then 2e in 16 is 46 in base 10. 1bf in 16, we want to convert it to hex. So it's the same process. 1 times 16 exponent 2, b times 16 exponent 1, f times 16 exponent 0. So this is 1, f is 15. The 16 exponent 1 is still 16, b is 11. 16 exponent 2, yellow.
Madam, please kindly go back.
This one.
Yes. The E, how come it changed to 14?
Is E not 14? Hold on. E is 14. We are doing hexadecimal.
Oh, okay. Okay.
We are doing
Okay, thank you very much.
Okay. So that is the same thing that is happening here. And we finally, 1bf in 16 is 447 in base 10. It's 447 in base 10. So we have, more examples. Convert this hexadecimal into their decimal. So 7a16, we have this. And then you will solve, simplify, you get this. The same procedure for 3f16. You also follow the same procedure. You get 63 base 10. So there are more examples here. I have said, please go ahead and solve them. If you put them there, madam, is CD base 10 equivalent to this in decimal? I would answer yes or no. Now we have this table, and they call it a comparison table. That's what it said in your notes. So 0 in binary is 0, 0, 0. In octal is 0. In hexadecimal is 0. If you pick 26 in decimal, this is its equivalent in binary, equivalent in octal, equivalent in hex. So it's a comparison table. And we are going to use that in the ones that are left. So we want to convert from hex to decimal, from hex to decimal, hex to decimal. So we have comparing decimal. For example, when you see 23 in base 10, like what I did, 23 in base 10 is equal to this in binary, 27 in octal, 17 in hex. So that is it's over here. That is it over here. Then we have, so conversion from decimal to hex is achieved by repeatedly dividing by 16 and noting the remainder at each stage. So we have 447 base 10. 447 base 10. This in hex, we want to convert this to hex. 447 divided by 16, you note the remainder. And then at the end of it all, the same thing starts from the down. But because it is hex, hex doesn't have 10, 11, 12, 13. So when you get something from 10 going, replace it with the alphabet. So 11 in hex is B, 15 in hex is F. So replace it. So what you get is 1BF16, which is the equivalent of 447 base 10. So converting from decimal to hex, you repeatedly divide by 16. So we have this as well. We have this one as well, 37 and base 10, 108 base 10. You want to convert them into hex, repeatedly divide by 16. So 37 divided by 16, 2 remainder 5. 2 divided by 16 is 0 remainder 2. And then this is what you get. So 2, 5 in base 16. If you take the 108, you do the same thing. What you get is C6, 6C in base 16. 6 is there, but 12, put the alphabet there. So you get 6C in base 16. In base 16. So you have these examples that you are supposed to do the conversion. Convert the following decimal into their hex. Convert the following decimal into their hex. So take this, if you are converting it into their hex, what do? Repeatedly divide by 16. If what you get, the remainder is more than 9, 10, 2 to 15, please replace it by the alphabet. So these are the exercise for conversion for decimal to hex. Now we want to convert from binary to hex. I think that's the last one. Convert from binary to hex. To convert from binary number to hex, the binary numbers are arranged in groups of 4, starting from the right to the left. And a hexadecimal symbol is assigned to each group of 4 binary numbers. So you have binary, converting it to hex. If you have it like this, arrange it into groups of 4, starting from the back. Starting from the back. So you see this one, we have 101, then we take the next 4, then we take the next 4, and then the last 4. And what do? Just that table, the lookup table, where you have this equivalent to this one. These binaries, they have its equivalent here. Then you do the replacement.
Please, will the table be always given?
The table should be given just to make you faster. But then I'm saying, even if the table is not given, I can still draw all these ones. You can still do. It's just addition of 1, addition of 1, addition of 1. But because it's in binary, here, if I add +1, I can do 002. So the 1 will come forward, then the remainder is 0. If I do this +1, I get 0011. If I do this again +1, I get 1 + 1 is 2. So I have to do a carry forward, making this one 0. Now here, there's already another 1. So I'll do a 1 plus another 1 and also give me 0. So the 1 will go forward. So the table will be given for faster workings. But then if it is not given, you should be able to do your own table. But then please, I will beg that the table will be given for you. So looking at the numbers, when you group them into 4, like this, and we have the numbers, this replacement 1011. Let's go back. What is 1011? 1011 in decimal, or in hexadecimal is 9. 1011 binary in hex is 9. So that is how come we got 9 here. So you look up the table and then you do the replacement. 1110. Let's go back and see. 1110. 1110 is E. 1110 is E. So just look at the table and then you fill it up.
Okay,
grouping them in 4. Yes.
I don't know whether this one will work. What about converting the binary to decimal? Then later on, you convert the decimal to the hexa.
You are free to do that. It is not wrong. You are free to do that. You are free to do that.
All right, madam. Thank you.
Okay. So conversion from binary to, that's what it's in. Alternatively, we can multiply each group of 4 by the powers of 2 as in the following. So, and see, when you are doing this, you are doing like the decimal kind of thing, conversion to the decimal kind of thing. So each group of 4, you can do it this way. You get a number here, and then you put them together all in base 16. So you see E7A9. E7A9. So you can, from the binary, you can convert the whole thing to decimal, and then from decimal to hex. You can feel free and do, but you shouldn't get different answers. It should be the same answer. But the question I want somebody to ask, nobody has asked. The conversion of hex from hex to binary is the reverse of from binary to hex. For any given x hexadecimal, we look for the 4 binary numbers that represent each hexadecimal. So when you have this and you want to convert to binary, what is the 3 equivalent in binary? You put it there. F equivalent in binary, you put it there. C equivalent, 6 equivalent, you put it there from the table over there. So it is even much simpler from hex to binary if you use the table. Likewise, from binary to hex, when you group them into 4s, you can replace it with whatever is in there. So for these 2 examples here, there's somebody sending a message.
Yes, please, madam.
Okay.
I wanted to ask this question. Is it not having a negative or point something as you did in the octave?
So let's say you have a negative, so meaning that I have this point 0, 1, 0, 1, 0, 1. Continue like that.
Okay.
So look for the, also after the decimal, put them into groups of 4.
All right.
Put them into groups of 4, then use the table to look it up, and then you are good to go. I think there was an example like that. There was an example like that. I forgot it. So if you have a decimal point here like this, maybe 0.01010001, what you do at the back, you do the same thing. So group them into 4s, then look up the table and do the replacement.
All right, thank you.
Okay, so solving these 2, I think the solution is here. So what we have first is the 110110101. So I think we can divide it into 2, and then you do the replacement. This one is 6, this one is D. So you have D6 in base 16. The second one, group of 4. This one is 7, this one is 6, 6, 7 in group in base 16. That is what you have here. We have another, convert from hex to binary. So you have 3F, and that's, so 3F, you have it like this. What is the binary equivalent of F? It is 1111. What is the binary equivalent of 3? The table will show you 0011. So 3F in base 16 is 11111. The leading zeros was thrown away in base 2. Again, A6 in base 16. What is 6 in binary? You put it there. What is A in binary? You put it there. And so it will be 10100110 in base 2. And then you are good to go. But the question I wanted somebody to ask, so these are more examples and their solutions over here for you to read. But what the question I wanted somebody to ask is, so madam, what if they put them into groups of 4? What if some that doesn't reach? That's the question I wanted you to ask. This one there, because you see, that is why students. Pardon?
The question again.
The question I wanted you to ask was, it is saying that put them into groups of 4, isn't it? If you have it like this, and you are to convert to hex, put them into groups of 4. I see when you are teaching, you present the nice example. When you are going to ask exam question, then you bring the Hudius question. So these are what I want you. This is the question I wanted you to ask. Now, when I what if we are grouping and then some is not up to 4? What do we do?
Okay. So that one, let me suggest.
Go ahead.
You will start from the first one. So let's say the ones that would be up to the 4.
Assuming I have one here. I have additional one. How do I do it?
So this one, it will affect the last one. The last one. So when it affects the last group, we have one. It will be something like 1, 1, 1, 1. The first 4.
The first 4 will be 1, 1, 1, 1.
Yes, please.
Before the rest?
So,
no.
Before the rest. So it means it will affect the last one.
No. Always start the groupings from the back.
Okay,
the groupings, start them from the back. So this 01001 comes down, then continue 0101, that comes, then you have 1110, that one comes, then you have 0111, that comes. Assuming there's another one in front here, that means it's the only one standing.
Yes, please.
Now what you
and
do
that
is,
one will be, I think it will be 0001.
Exactly. Pad it with zeros. Pad the zeros to the most significant side, not the least. Don't take the one in front and add the 3 zeros behind. No. The 3 zeros should be in front. So you have 0001. 0001. Don't do 1000. That is different. So if you're grouping, you're putting it in groups. Start from the back. If there's any leftover, pad it with zeros. Don't pad at the least side, pad from the most side. So that is it. Any question? So this is where we will end, or time will permit us. So I will report back that this is all that we could do. Stretching even the time said that this is all that we could do. So the questions will come from these angles anyway. So that is it. Any question? Any question?
To relate to the first one, the exponents and the radicals.
Okay. Radicals.
With that one, and there was an example in it wasn't in your presentation. It was in the main book.
Okay.
If I'm to read the example out, it is we have bracket open 1 plus s square bracket close.
Okay.
All raised to the power 1 out of 2.
Okay, so you have 1 plus x squared, all raised to the power 1 over 2.
Yes, please. Minus
1 over 2. Hey.
Again, I'm not done reading the question.
Oh, okay.
So,
okay, please go ahead.
Okay, so the first term, as already mentioned, which is bracket open 1 plus x square bracket close 1 raised to the power 1 out of 2 minus x square, then bracket open 1 plus x square bracket close raised to the power -1 out of 2, all divided by 1 plus x square. Madam, please, do you get it?
Okay, so let me. So so the denominator is what? 1 plus isn't it?
Yes, please.
Then here we have
Yeah.
1
1 plus
plus x I should have written. So this then what? Minus 1 over 2.
No, please. 1 over 2. Just 1 over 2.
It's just 1 over 2. Okay.
Yes, please. So the second thing.
Then I come here and minus
x squared.
X squared
Then
into
bracket.
brackets. Okay.
1 plus
1
x squared.
X squared. All also exponents.
Negative. Yeah, exponents. Negative 1 out of 2.
One over 2. So this is the question.
This one is negative.
That one is negative.
Yes, please.
Okay, here is negative. Okay. And you're asked to simplify.
Yes, please.
Hey. So did you solve it?
Yeah, I solved it, and I did not get the same answer as the one in the manual. Yeah, and with the book, the way they have done it in it, it's quite complicated. They've did some factorization with this, the top one, the numerator. They factor, which is 1 plus s squared bracket, okay, into bracket 1 plus s squared minus 1 out of 2. Then bracket open, another bracket open, 1 plus s squared bracket close minus s squared bracket, all bracket close. And it was complicated. So I solved that numerator, the factorization they did. I wanted to solve it and see if I would get this one, the question numerator back. But it didn't happen that way. So I wanted to seek clarification.
Maybe hungry. But we'll do this. We'll do this. Maybe we'll continue on the platform. But what I'm seeing is you have this. Oh, sorry. The 1 plus x squared. I can see it's common amongst them. I can see it's common amongst them. So what I'm just suggesting this part of the equation.
Okay.
We can turn it into 1 over square root of this, so that we can do away with the negative exponent here. So it can be x squared multiplying 1 over 1 plus x all squared. And that's raised to the power half.
So that means that's very term will be denominator in the numerator.
Yeah, so it turns out to be a denominator, a denominator in the numerator. And then, so from there, you can. I've not seen that question, but please let me solve it, and then I'll get back to you in the platform.
Okay, madam. Thank you.
Please, are we all okay?
Yes.
So this particular,
yes.
He's saying it in the book. I've not seen it anyway, but then I'll try and solve this and check with what is happening in the book there. Then please, I'll get back to you on the platform.
Okay, madam. Thank you.
Okay. Yes.
Yes, madam.
Okay, madam.
About the synthetic.
Yeah.
Yeah. Please, can you go over it again?
Please, briefly for the synthetic, what I'm saying is, if you have a polynomial given, divide this by that. What you do is bring all the coefficients down. So this 2 that you're seeing here is this 2. Minus 6 is this minus 6. This 4 here. Minus 8 is here. This 2 is coming from the divisor. X equals 2. It's x minus 2, but when you do equals to 0, x will be equal to 2. Then that is this 2. Now what is left is the first one here, bring it down. The first coefficient, bring it down. The next is to do a multiply add. Multiply add. So the multiplication is done 2 times this 2 down here. You get 4. Put it here under the next one. Then you add them together. So minus 2 plus 4 will give us minus 2. Minus 6 plus 4 is minus 2. That is what is written here. If you read the small here, you will understand how we got here. Then the next step is to repeat again. 2 times minus 2 is minus 4. You put it on the next. 4 minus 4 is 0. That is what brought us here. 2 times 0 is 0. You get minus 8 when you do the addition. So please, are these okay with you? Please, is this okay with you?
So, madam.
Oh, he's gone.
Madam, I'm there.
Okay, so this part of the table is as a result of the question. The question that was asked. Yes, the question that was asked. Just bring the coefficient of all of them down. Whatever you see here is in the divisor when you equate it to 0. That is it. Then you do the first thing, bring the first one down just the way it is. Then moving forward, multiply, add until you reach here. 2 by 2, I get 4. Minus 6, 4, minus 2. 2 minus 2, minus 4. 4 minus 4, 0. 2, 0, 0. Minus 8, 0, minus 8. Then you get here. Now, how do you interpret whatever you have here? The last number is the remainder. So the remainder for this particular equation is minus 8. The rest are the coefficients, starting from x is equal to 0. So here, x is equal to 0, x exponent 0, x exponent 1, x exponent 2. That is the rest remaining. So your answer is actually 2x squared minus 2x plus 0, but we don't write the 0. The remainder is minus 8. So if you're actually writing it, this is your answer. 2x squared minus 2x plus the remainder over the divisor. Please, I hope you're okay.
Yeah, madam, I'm clear. I'm clear.
All right. So that is the synthetic. That is the synthetic. It is a lot for 4 hours. However, when you sit down to go through, anywhere you get stuck or you're confused, please just drop a message. A friend can help. I would also help.
Thank you, madam.
All right. So then I will wish you all the best in your quizzes and your exams, and I hope everything goes well.
Any area for the quiz?
Any area for the quiz? I will try and get it for you.
Okay.
I'll try and get it for you, but I don't know. I am not the one going to set the questions.
Okay. Since the content is too broad, there are not.
So I would ask if there are any areas to be given out, but then I would
for the boys to go over.
I hear.
Hello, madam.
Hello.
Oh, thank you so much.
You're welcome.
Yesterday I was going through the book they gave us at page 11. This is a simple question, but they say write the following set in set builder form, and the question, the answer, what they gave was B is equal to curly bracket open. We have 3, 6, 9, and 12, and the answer they gave here is B is equal to S. X is such that X belongs to 3n, and n belongs to, that is bigger n. Then comma 1 is less than or equal to n. It's also less than or equal to 4. So that was the answer.
Using set builder notation.
Yes.
And their answer is X is such that X belongs to 3n.
Yes.
That n, is it big or small?
Small.
Small n. And the big N.
And small n belongs to big N.
Okay. Small n belongs to big N.
Then comma.
Then comma.
Then 1 is less than or equal to small n. And that one too is less than or equal to 4. Then they close the curly brackets. Because I was thinking that it would be B is equal to S is such that 3 is less than or equal to X and less than or equal to 12.
X is such that X is
X3. S is such that S is 3 less than or equal to X, then less than or equal to 12.
X is less or equal to 3. That is also less or equal to 12.
Sorry, X is greater than or equal to 3.
X is greater than or equal
less
to 3.
than or equal to 12.
Yeah, but when you do it that way, what happens to 4, 5, 6? That is your answer that you are given.
Yes.
That means the sets can contain, but I was thinking it's a multiple of 3. It's a multiple of 3. That is how come he said the 3n.
3n.
Yes, the 3n. And now he's explaining where the n is starting from. So the n is starting from 1. So you don't just, when you do 3 times 1, you get 3. When you do 3 times 2, you get 6. So the answer is what he gave. It is 3n. It's a multiple of 3. So it is 3n. But now he's explaining where the n starts and ends.
Okay.
That's the second part. So n starts from 1 and goes all the way, including 4. That's where it ends.
So that means where n is equal to, okay, so 3, you mean 4 times n will give you the 12.
The 12. 4 times 3 will give you 8. 3 times 3 will give you the 9. 3 times 2 will give you the 4. And 3 times 1. So x is such that x is 3n, belongs to 3n. That is that is how you get the terms. But then where am I starting from? Where am I ending?
Okay.
That is why it's giving you the n belongs to from 1 to 4.
I was thinking that where the small n is means every number, when you put the number there, it should give you the values of the b. It means that whatever number I put there should be either greater than or equal to the one here, the one behind it.
What it means is, how do I get my terms in B? The function is 3n. How do I get the terms in B? It is 3n. Now the n, where do I start from? Because it can be -0, it can be -1, it can be -2. So it goes on to tell you where you are starting from and where you are ending. But for yours, if you just say x is such that x is greater than 3, less than 12, meaning that I'll do 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
Yes.
And that
but
is
this is limited. This is multiples of 3. Okay.
Exactly.
Yes, madam. Thank you so much.
You're welcome.
God bless you, ma'am.
Madam, you do all.
I am hungry. So we will end here.
Oh, sorry.
Mike, can you buy madam food?
Oh, yes, I'll do madam food. Madam, offline talk.
I hear. We will talk. Please, let's talk on the platform. By
I'm sure madam likes.
Bringing all your questions and then we will answer. It makes it fun anyway. And when I say I will revert, meaning that I am busy somewhere. I have seen it, but then mostly I want the time where I sit down all by myself and then I answer. So when it is around the 10, 11 day, that's the time I get to myself. I have a small baby that is draining all my time, plus their elder brothers and sisters. So mostly when I tell you, please, a minute, I am going to attend to him. And I thank you so much for all tolerating all those ones there. So if I say I will revert, I have seen it, but then I will answer. That is what it means. In the nearest possible time, I will answer. That's what the revert means.
Okay. Thank you, madam.
Okay. All right. So all the best to all of you. If there's any further information, please, I will drop it on the platform there until you finish your exams.
Closed, Ame.
Okay, so thank you very much. I am signing out. Bye-bye.
Bye. Thank you so much for everything, ma'am. God bless you. We do appreciate whatever you have taught us, and we thank you so much for your patience as well. Thank you.
I beg you, who has the link to the peer-to-peer group? Or yesterday there was this issue on the first lecture, communication design. He gave an assignment, and
we are not doing communication.
Oh, okay. Are you doing operating systems?
Yeah, exactly.
OS.
We are doing OS.
Yeah, yesterday you promised of sharing the slides, and I learned it on some peer-to-peer group, WhatsApp group or something.
Yeah, I don't belong to that group.
There's nothing there.
Please, I have the slides, so I will send it on our platform.
Oh,
Oh,
okay,
okay.
okay. Do what? Boys are what? We want to go through again. Charlie, no be easy. The learning days will
Which
be
group are you
good.
talking about? Which group are you talking about?
You know, mathematics and IT group.
Okay.
So, Francis.
Yeah, I'm sending it.
Francis.
Yes, I'm sending
Oh,
it right now.
okay. We are waiting.
Is anyone offering communication design here?
I do.
Yesterday the lecturer gave some assignment.
Well, I'll check it and then get back to you. Okay.
All right. Alonso.
Mr. Alford. Mr. Alford.
Yes, please.
Please let me have your contact here.
The course outline. No.
No. Your contact.
My contact.
Yes, please.
All right. 0548.
Okay. 0548.
77.
Okay.
07.
Okay.
35.
Okay. Thank you.
Welcome.
Mr. David. Mr. David. Mr. David.
Yes, sir, my brother.
What are you still doing in the classroom?
And you, what are you also doing here?
I just came to inspect.
Personally, I've forgotten that I'm even reading the notes, so I've forgotten that I've not left the page.
Oh, okay. That's don't leave it. Don't leave. Stay here.
I shouldn't
Stay
leave.
here with me. Stay here with me. I want to. Yes. I want to, share some screen to see whether my destiny I can do the presentation.
Oh, you are doing presentation today?
Not today. I mean, the one we have to present on Wednesday.
The methods of teaching,
Charlie.
No be easy.
No be easy. Charlie, the first one, no.
Share with me. Share with me.
I'm going to share. First day that I did it, Charlie, for me, I know it's not. I don't know whether you heard what I was saying.
You have been able to do something and you say it's not. What about me? I've not done it.
It's very bad.
Boy.
It's very, very bad.
My friend, not the whole of that's last week, I've not had the opportunity to even open any book. You're having issue with your system.
Connected.
Your system is very slow. So close the screen you are sharing now. Stop sharing. Okay, it's now okay.
My system is very slow.
Yeah. You close it and start again. Okay, now you can start. Did you choose a window? When you are sharing, the screen that enables you to select the type of sharing you want to do. Choose the middle one.
I should close.
Now click on the share screen. No, I said you should click on the share screen.
So you mean I'm not sharing it?
No. As at now, you're not sharing.
Oh. You let me start everything afresh.
Start all over. Okay.
I want to choose read. I will even choose read.
You want to choose what?
I think this one.
Do you know what you have to do? When you click on the share screen, Can you hear me? My brother. Edu.